Okay, okay. All right. Relax, relax. I'm here. I'm here. Yeah. Okay. Uh, shit. What is okay? Second thing here. I forgot to name my workspaces, so sometimes like things are opening, but I don't know what they are. I wonder if it still works when I start the computer up. It doesn't. You gotta. I think you gotta start like Minikube. Minikube. Start. Yeah, I think like the Minikube needs to get started before everything else starts on. So if I do Docker PSA, oh, all the other things are still running, which is cool. So yesterday after the stream, I kind of got bored and I ended up creating a Datadog, sorry, Sentry account. And then it's a free one I'm using, but I like that it works. Like I'm doing, like test. Cool. So now next time that I experience any what can I call this thing? I experience any production errors, they will show up here. Is it still? Where the fuck did we run this thing? Oh, we ran it over here. That's why. Okay. So I'm gonna do here kubectl get all. Okay. So now this should be running. Cool. Cool. I like it. So ingress nginx, let's encrypt. How do we get this thing to work with the ingress? What the fuck is Helm? Like, I keep seeing this shit like as if like it's a requirement to have it, but I don't really know what it is. Celebrate good times. Come on. Let's do YouTube. No, fuck. Fuck. Can I disable this shit? Okay. Nana again. She is taking over the Kubernetes section.
The basic common principles and more importantly its use cases to when and why we use Helm will make it easier for you to use it in practice no matter which version you choose. So the topics I'm gonna go through in this video are Helm and Helm charts, what they are, how to use them, and in which scenarios they're used, and also what is Tiller and what part it plays in the Helm architecture. So what is Helm? Helm has a couple of main features that it's used for. The first one is as a package manager for Kubernetes. So you can think of it as apt, yum, or homebrew for Kubernetes. So it's a convenient way for packaging collections of Kubernetes YAML
that makes
files
more sense now.
and distributing them in public and private registry. Now these definitions may sound a bit abstract, so let's break them down with specific examples. So let's say you have deployed your application in Kubernetes cluster, and you want to deploy Elasticsearch additionally in your cluster that your application will use to collect its logs. In order to deploy Elasticstack in your Kubernetes cluster, you would need a couple of Kubernetes components. So you would need a stateful set, which is for stateful applications like databases. You would need a config map with external configuration. You would need a secret where some credentials and secret data are stored. You would need to create the Kubernetes user with its respective permissions and also create a couple of services. Now, if you were to create all of these files manually by searching for each one of them separately on internet, it would be a tedious job. And until you have all these YAML files collected and tested and tried out, it might take some time. And since Elasticstack deployment is pretty much the standard across all clusters, other people will probably have to go through the same. So it made perfect sense that someone created these YAML files once and packaged them up and made it available somewhere so that other people who also use the same kind of deployment could use them in their Kubernetes cluster. And that bundle of YAML files is called Helm chart. So using Helm, you can create your own Helm charts or bundles of those YAML files and push them to some Helm repository to make it available for others, or you can consume, so you can download and use existing Helm charts that other people pushed and made available in different repositories. So commonly used deployments like database applications, Elasticsearch, MongoDB, MySQL, or monitoring applications.
Oh shit, sorry. I didn't have the chat open.
Kind of complex
Greetings and hello there, Jeremy. Jay, pay attention. Fuck. How you doing, dude?
So using a simple
Greetings.
install chart name command, you can reuse the configuration that someone else has already made without additional effort. And sometimes that someone is even the
You are here to win. What's going on with your life, bro?
This functionality of sharing charts
Spent 4 hours debugging something. Holy shit.
Was one of the contributors to why Helm became so
It was the expected result.
Its alternative tools.
What
so now,
language? Just purchase Bleach on Amazon.
You need a deployment that you think should be available.
Oh my god.
Look it up either using command line, so you can do Helm search with a keyword, or you can go to either Helm's own.
Okay, so this makes sense. And then I'm gonna look into this thing here. Also, like, I wanna make sure, okay, this is less encrypt. Okay, cool. The easiest way to install Cert Manager is to use Helm, a templating and deployment tool for Kubernetes resources. First, ensure the Helm client is installed. Okay, let's go install the Helm since this is gonna be part of our life now. Brew, fuck you. Okay, at least there is this. Okay. Getting started with Helm. Let's do it. Install Helm. Okay. Okay. Mamma mia. All right. So, deploy the Nginx ingress controller. Ingress Nginx. Damn, what you doing today, Nick? Depression, bro. After that code, what language was it? Was it Java? You rewrote 70 lines of code. Okay, that's not bad. 70 times. Okay, I kind of want to like save this, but hold on. I want to see do a git diff on Java. Damn. Now he's meowing. Oh my god. He waits until I literally sit on the computer and get started, and he's like meow, 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 meow. All right. Give me a sec. Mr. Kitty, where's my boy? Blah 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 blah. Ah, okay. Okay, before we do this, oh shit. Activate. I sort. Damn. Yeah, I'm gonna have to make some. So this doesn't give me a fucking thing, but what the hell? Python get exception from traceback. Gonna go and clean. All right, my dude. Take it easy. Keep it real in the hood, whatever. Okay, so I think let's do a bit of an experimentation here. Okay, we're gonna say import who that city I live in. Sometimes, like I feel like your mind is like the hood too, you know, like you're gonna chillax a little bit. Okay, so this does work. I like it. I like it. I don't know if that is gonna do something. It's a class. Exception type, extension only, and exe traceback. Motherfuck. Hold on. What the fuck am I looking at? Flashbang, right? Yeah, I was tacking. Okay, traceback. Let's see what the fuck is this. This method provides a standard interface to extract, format, and print stack traces of Python programs. It exactly mimics the behavior of the Python interpreter when it prints a stack trace. This is useful when you want to print stack traces on a program control, such as in wrapper around the interpreter. File and use a dump Python traceback on a file after a timeout or a user signal. Okay. Print TB, print up to the limit stack traces, print exception information and stack trace, print stack, okay, extract TB, sometimes representing list for process, extract stack, format list, format exception. Oh, it gets it with sys.exception? Motherfucker. It's that simple. Breadcrumb! How you doing, my man? I was at your I was at your stream. It just said be right back, but you never came back, so I had to leave. I was looking at your be right back screen. Okay, let's say print. We're gonna say from traceback. Okay. We're gonna say here print traceback print exe. I'm gonna say print from sys exception. Okay. Print sys dot exception. Hold on, was it? Oh yeah, it's a open close. I was working on some code, then my daughter boss came home, and then pizza showed up, brought it back. Well, pizza take priority. I know that. I like it, you know what I'm saying? Has been super foggy today, so I was hoping having stream on would help me walk through things. What are you working on? Are you doing some Python stuff again? Or is it the C# with the Maui thingy? I don't remember what it was, but there was like a C# thing that you were working on, the unit testing stuff. Okay, I'm gonna test this intentionally. So let me see if I can fucking get this thing like utilized. I'm gonna do it in the URLs before I do that. So let me go over here and break this bitch. Path. I'm just gonna say here YOLO, and then it's gonna be call me. Okay. And then when I say def, call me request args quargs. I'm gonna do try raise. Working on this Python code to take a markdown file and convert it to HTML so I can display goals on OBS. I had it working, but I wanted to make it more configurable. Then I thought it would be good to work off of file change events instead of having a constant loop reading, writing the file. So find a Filelib watchdog that seems to be the right path. Oh yeah, I was, I am using watch me do the watchdog, yeah. Like I'm using it, excuse me, fucking, not that entry point. Yeah, this one right here. This is part of the watchdog. And then watch me do, you can do like auto restart and you can assign a pattern, what kind of files, like matching the pattern you want watching, you want being watched. And then if it is a directory, you can say like recursive, and then what kind of thing. And then this is the command that you want to call. And then these separates the parameter that you want to send to the command that you are calling. So yeah, I'm using it that way. If this works, this is gonna be so fucking awesome. Very cool. Yeah, I love it. Because like Daphne doesn't have hot reload. Yeah, this one doesn't have hot reload. It's not supported apparently. Okay, I think okay, so if I go to YOLO right now, okay. So I should see an error here. Come on. I think it might take a few minutes or seconds. Oh, there you go. Oh, this works. I like it. Love me a lot, baby, bro. Ching, motherfucker. And I'm catching it right here, and it actually finds it from right there. That's more like it. Okay. So basically, this is what we're gonna do over here. I don't really have to do any of this shit. Okay, so duplication, cool. Okay. Now we can actually do the thing. Production. Let's shit. Hold on. I'm gonna have to take out. I'm gonna do this off screen because it exposes actual key that I can't really change. So give me a second here. Okay. Yeah, I gotta do this off screen, guys. I'm sorry. I can't display this. Coolios. Okay. Let's add something here. This is the last defense for capturing and displaying an error message. The error message is being caught. The base middleware. Base middleware process exception. Okay. What the fuck? Okay, so at least figured out where the issue was coming from and then resolved it, and then now okay, I can just say flake 8 sweetness. Cool. We are set. And then now I'm going to do a quick git diff here, guys. 1 second. Okay, let's go. Hop put. Okay, the tests are gonna fail, but it's okay. Don't really give a fuck. That's fine. So now I can actually follow the documentation here on this one. Cool. I am glad you agree. I need some tunes. Hopefully by end of the day, my site is gonna be actually up. That would be so cool, isn't it? Yes. I am fucking scared actually to do that, but rendered manifests contain a resource that already exists. Unable to continue with the install exists and cannot be imported into the current release. Involved ownership method data label validation error missing key and is managed by must be set to helm annotation validation error missing key. Error missing key must be set to default. Okay, so I think we already have it, so it's fine. Quick start example uses 3 manifests for the sample. The first 2 are sample deployment and an associated service. Okay. Ingress resource is what Kubernetes uses to expose the example service outside the cluster. You will need to download and modify the example here. kubectl get ingress. That's the one that I have, and the hosts I see both of them over here, filelib.com and api.filelib.com. So this is my API, this is my thing. Oh shit, hold on. By the way, I kind of forgot to do this. I have my dark synth music playing still, and it was blending super cool and in sync with your tunes for a minute there. Nice. Yeah, I'm playing this from the Chill Synthwave, Chillwave Mix, Neon Paradise, royalty-free, copyright-safe music. I got this from Griffin. He plays it on his stream. This has to change. So what this is gonna do, all the API URLs are gonna be part of the main. So when I am here, instead of saying like API, right, it's not found right now, but if I do upload auth, it should show up. Upload should fucking show up. Yeah, API upload index. Oh, it's fuck, it's just auth. There you go. Ha 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 ha. Reverse, and then we're gonna do here API upload API auth index. Nice, isn't it? I like it. Shit, I finished my tea. I'm gonna get some more tea. Give me some tea. Give me some time for the tea. Okay. So this is good. And then I can just say here, upload. Right. Oh, look at this. This is coming together so nice. All right, let's continue. Let's continue. kubectl get ingress. So this will be 192.168.49 and 2. I think it needs to be just this. Holy shit. Something went wrong. Blah, 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 blah. But what the fuck is it? Oh shit. I think I'm gonna see it here now. Alright, come on. Ah, come on, you motherfucker. Something just broke. I should see that error. Something went wrong. Oh, it's inside the container, of course. We are not gonna see that shit. Alright, I think it's time. So we're gonna do here. So we're gonna do this 2. Build it, and then we're gonna push it. I'm gonna be a Kubernetes engineer if it keeps going like this. Alright, while it does this thing, I might have a message here that I might need to check. Okay. Oh, thank you. I appreciate it. Alrighty. Last chance, fancy pants. Okay, so version point. No, I just published it, motherfucker. Oh no, I didn't. I just gotta make push images. They're coming right now. It's gonna take about a second or two. This time they're gonna have error logging, so I'll be able to just log my errors directly to Sentry from within, and then I'll see like whatever the fuck is wrong with it. Okay. Come on. Stop fucking caching everything. Yeah. This one right here. So I'm gonna have to go here to my Kubernetes now. Okay, let's close this. And then where I do API. Oh, I changed it to Django. Oh no. I need Django.yaml or API.yaml. There you go. So this here is going to be 2. Cool. Actually, hold on. Let's Let's make sure. Yeah, both NextJS and this uses the same version. I'm gonna have to like parameterize this fucker, but it'll happen. So we're gonna say make K8. Okay, this should be good. Oh, it's killing all my fucking locals. God damn it, I forgot about that. So the API, it's gonna have to change it, right? Unchange, configure this one right here. And then the Next.js. Cool. Okay. Now we're gonna take kubectl get all terminating, running. So Next.js is running, Postgres running. This hasn't changed, so it's fine. And then the new one is already up. Coolios, brother. I like it. So if I'm here now, and then I don't have any problems right now, no logs. If I do this again, oh, this is the wrong one. What the fuck? This shit works, bro. Something went wrong. Now we're getting an issue. I don't know what it is, but please log it. Template does not exist. Yes. The homepage tries to do shit that it doesn't have. But now, what I can do here, okay? Where the fuck is my C and V? I just keep getting confused on these things. Okay. Now, if I do sign up, it always keeps giving. Okay, before we do that, actually, kubectl get pods. Okay, I need to do kubectl exec, and then we're gonna change this thing to that name. Okay, and I need to manage.py. Just migrate. Fuck it. Okay. So, we're gonna come down now, and I'm gonna try to create an account. Hopefully, it's not gonna do HTTPS like it did last time. So let's go. Actually. It gives me 500, and I don't know why. But please tell me what the fuck it is. Okay. It might take a second here. It's giving me a 500, and I just don't know why. Filelib.com API user. What the fuck is the problem here? Because I think yeah, it's getting the error from 500. Hold on, the error doesn't even reach. The error doesn't even reach here. What the fuck? Hold on. It's coming from NextJS. There is no request coming here. What the fuck? You dingleberry motherfucker. Yeah, I gotta figure it out. What the fuck is going on there? Nothing shows up on the fucking thing here. Jesus. I don't know how to get around this thing, to be honest. It just gives me like straight up. Yeah, we can't access it directly because some crazy shit right there. Filelib.com API user. Yes, 404, which is okay. Then this gives me a fucking network error because it tries to log in to fucking HTTPS. Why? Okay, might have to like redeploy this motherfucker again, but let's go front end and then this here. Mm-hmm. Protocol, END protocol. So fuck. Anyways, that's okay. Now let's continue on this. Once we get this thing working, I can try to see what the fuck is wrong with it. Oh, holy shit! Create this definition locally and update the email address to your own. The email is required by Let's Encrypt and used to notify you of certificate expiration and updates. So I think this is the same thing. Okay, let's read this and kind of try to understand what the hell's going on here. The Acme server URL, encrypt, staging. Okay. Pong Linus, how you doing, my dude? tell me what to build with Django. Like for practicing purposes, I'm not sure where this is going on. Like a hobby project. Oh. Create a dating website, bro. Create a dating website, but no swiping. You just auto-match people, and then based on the credentials of each user setting up. It could be any criteria that they can assign. They can say, interests in game, and you can say, match me with people who plays Dark Souls. And then you are a dude and there's a lady on the other side. Lady says, I love Dark Souls players. And then it just says, oh, I love playing Dark Souls, then match him. Gonna sit on that idea. That can be a criteria too. If you're into that, but Advent of Code just started. I heard of it. I don't really recall what exactly it is. Is it like those challenge thingies? Like they have challenges and then you can, like you're solving it in your choice of language or something. Yeah, I remember seeing it. Like it was the hype for some time on Twitch for a little bit. I just don't really recall like what it was. But thanks for clarifying it for me though, because I kind of forgot about it. I don't know anything about the network calendar. Chocolate in it for each day, bruh. Instead of chocolate, you get a challenge that you can solve with your programming language of choice, bro. Yeah, I remember like Anthony was doing it one time. I caught his stream doing that. 23 is like we are in the last month, brother. Not found. It's only in December? Ah, gotcha. So, how do you see this? What is this AOC? Is that this senator lady from New York? Ocasio-Cortez or something like this? Oh, it's Advent of Code. Oh, it's like today's thing. Something is wrong with global snow production. Like snow production meaning like cocaine, right? Like from the Scarface. like yayo. And you've been selected to take a look. All right. The elves have even given you not yayo, yayo. I don't want to Google it right now, and then but Y-E-Y-O, yayo. That's what he calls it. Scarface, yayo. It's with an A? Oh no, what's the meaning of yayo? Look, it's E. What? He literally says yayo, like Rush, give me yayo. Look, it's E here in the soundtrack itself. Maybe like it's both? Yayo is how we say it. Okay. Dude, I just watched that movie, like very recently watched that movie, like last week or something, and I remember reading the subtitles. He literally says yayo. That's why. Anyway, yayo production is slow. Alright. I was even giving you a map on it. They've used stars to mark the top 50 locations that are likely to be having problems. You've been doing this long enough to know that to restore some operations, you need to check all of the stars by December 25th. Oh, collect stars by solving puzzles. The puzzles will be made available on each day in the advent calendar. The second puzzle is unlocked when you complete the first. Each puzzle grants 1 star. Good luck. You try to ask why they can't just use a weather machine, not powerful enough, and sending you the sky while your map looks mostly blank. You sure? Ask a lot of questions. Bruh. It's yayo. We gotta get figured out. And hang on. Did you just say the sky? Of course. Where do you think snow comes from? When you realize that the elves are already loading you into a trebuchet, please hold still. We need to strap you in. Damn. Sounds a lot of like yayo. We're making the final adjustments. The calibration document, your puzzle input has been amended by a very young elf who was apparently just excited to show off her art skills. Consequently, the elves are having trouble reading the boundaries on the document. The newly improved calibration document consists of lines of text. Each line originally contained a specific calibration value that the elves now need to recover. On each line, the calibration value can be found by combining the first digit and the last digit in that order to form a single 2-digit number. It gets pretty tricky later on. Okay, please identify yourself via one of these services. So you gotta log in. Alright, thanks. Great way to learn new programming languages. That definitely sounds like it. But I hate that every single fucking thing right now. You gotta log in to see our content. I'm like, no, fuck you. I'm not. Fucking annoying as fuck, bro. Like, they just want you to log in with everything. Like, bro. It literally says you have to. So I'm like, alright, no. Thanks. I'm good. I don't want to swear. God damn it. I don't know. Let's not use profanity right now. I've been saying a lot of profanity these days. I'm getting frustrated with this shit. You know, it's not good for my mental health. All right, I'm gonna get some tea. Give me a moment, yeah. Alrighty, we're back. So, fuck. So apparently there is a way to do that, but I don't know how to get around it, honestly. Okay, hold on. There's got to be a video here, right? We can just follow. Securing Kubernetes ingress with Let's Encrypt. I really hate these fucking headsets from Apple. Fucking Apple headsets. Such a piece of shit design.
Hi, everyone. Welcome. This is a DigitalOcean tech talk called Securing Your Kubernetes Ingress with Let's Encrypt. It's
This is a DigitalOcean TikTok,
and my name is Kim Schlesinger. Welcome. We're
That's
really
some
glad
last
to have
name,
you.
yo.
So a little information on what we're up to today. So this is our agenda. I'm going to do an introduction of myself and an overview of what I'm going to be covering today. And then I'll be doing a demo that will show you all of these steps. And then at the end, we will do a recap, just reviewing what we learned. And I'll answer any questions you have in the chat. So starting with some introductions. So first thing is, if you're watching, I would love to hear from you in the chat. So tell me, hi, my name is Justin, random Singapore. All together. I'm glad to have traffic from the internet coming into your cluster, and some of recommend following along with this, doing this on your own. I have options in the kit. You can either use Ambassador Labs, Ingress Controller, or Nginx. What I'm going to be showing you today is Nginx. So if you click here, and this is the set of instructions for what I'm going to show you. So if you want to follow along step by step, I recommend following along with this, doing this on your own. I've adapted it and changed it a little bit for this presentation, but this is a wonderful resource. We've shared it in the chat. And all right, watching this in the future, or you're watching this live and you want to try this on your own after the talk, I recommend doing chapter 3 of the starter kit there. And then if you are planning on following, go. And so this is the thing that might take you the longest to set up. So I bought a domain. It's called kubetips.online. But we're going to be linking a domain with our DigitalOcean load balancer, so traffic can come into the cluster and people can use a domain, not just an IP address. So domain you own. And then the tools that I'm going to be using, command line tools, I'm going to be using Helm, which is like the package management system for Kubernetes. I'm going to be using Doctal, which is DigitalOcean's command line tool. I'm going to be using kubectl, which is the command line tool that lets you interact with the Kubernetes API. And then I'm going to be using curl to do some testing. So you'll want to have all those things installed before you get started. And then in terms of like knowledge and skills, you'll be best served if you have some experience with a Kubernetes cluster. So if you've done a getting started with Kubernetes tutorial, or you've been maybe working with Kubernetes as a developer and you've used some kubectl commands, you want to have some concept of Kubernetes. You also want to have some familiarity with your domain name registrar's process for updating records. It's not too bad, but every domain registrar is different. And so just having some facility with that. And then you want to have just a knowledge of certificate. Will there be a cert manager for Kubernetes also? And yes, this is the diagram of what I'm going to be building today. And it's kind of a complicated diagram. But if you look over here, we are going to be installing Cert Manager, which is going to communicate with Let's Encrypt to enable TLS. So yes, we're definitely going to be installing and using Cert Manager. So good question. All right, that said, this is what we're going to be. Don't understand it right. Part here it says and about going to be by Kubernetes cluster, and in doing that, we're also going to create an external load balancer where all of our traffic is going to that. So I'm going to DNS so that my domain name is linked with the load balancer in the cluster. Then I'm going to create one backend service inside the cluster where we want to route traffic to. Then I'm going to configure the Nginx ingress rules. Then I'll configure a TLS certificate using Cert Manager and Let's Encrypt. And then I'm going to enable proxy protocol so that we still know what client IP addresses are when traffic comes into the cluster. So my slides didn't line up quite as perfectly as I was hoping, but that's okay. Okay, so first thing we're going to do, install the Ingress Nginx controller and create a DigitalOcean load balancer. And so let's get started with that. So first thing is I'm on my command line and I have a Kubernetes cluster up and running. Like I said, it's a DigitalOcean cluster. And whenever I'm starting something with a cluster, I just like to poke around in kind of a general way. So first thing I'll do is say kube control get nodes. I can see, excellent. So I have 3 worker nodes running. And then I like to do kube control, get pods from all namespaces to see what's in here. All right. So the only namespace right now that has anything running in it is the kube system namespace. So kube system is where the services that keep your cluster up and running get installed. And unless you're a Kubernetes administrator, you usually don't mess with the kube system namespace too much. So I'm going to be creating some namespaces and putting things in there. And then the thing that I want to do is I want to create an ingress and a load balancer, and I'm going to use ingress Nginx. So how do I figure out how to do that? So let me go back to my browser. Oops. Maybe. There we go. And I'm going to go to the Kubernetes package manager, like repository of projects, which is called Artifact Hub. So it's artifacthub.io. And we see this is the page that you land on. It says find, install, and publish Kubernetes packages. I want to install a package called ingress Nginx. And when I search that, there are multiple packages with that name. And so I have to figure out which one I want. And the one I want is the top one. And the way that I know that is the Kubernetes organization is what maintains this project. And so I'm going to go here. And thank you, Jimmy. That was my cat, Bowie. Just information that the ingress. Let's see. Okay, Vinod asks a good question. So this is forward-looking. They say, with certificate, are we securing the traffic between ingress Nginx and the Kubernetes service? What about
That's
traffic
a nice
between
question
pod
indeed.
to pod? Is that also going to be secured with certs? I'm not going to be able to show you that today. So I'm going to be showing you how we do TLS termination at the ingress Nginx controller. I would recommend researching how to do pod-to-pod traffic, encrypting that. And then we've got Mason saying, come for the Kubernetes, stay for the cats. Hi, Mason. Artifact Hub. So I'm like the Artifact Hub because you get a lot of information about it. It tells you what the prerequisites are. In Helm, you have to add the project's repository before you install the chart. And then it gives you those commands, and then gives you lots of different it says get the repo info. And so let's go back to my command line. If I say Helm repo list, these are all of the Helm repos that I already have installed on my local machine. Grab this command, and we'll look at that on the command line. So it's Helm repo add ingress Nginx, and then it has a URL for that repository. So let's add that repo. And it's always best practice, Helm repo update ingress Nginx, to just run the update command right afterward to make sure you have the most up-to-date version. Beautiful. And then it says install the chart. So we'll do that in just a moment. Bleeb84 made a comment. They said they didn't know the existence of this web. You can get so much around Nginx or how you cluster. And if you go down here to values, you can see some of the configuration options that you can set. And so these are some things. Let's see. I'm trying to see one that looks controller annotations. All right. What about if we get out of the controller section? Oh, there we go. Okay, image pull secrets, default backend. So just a lot of ways that you can configure your Nginx ingress in your Kubernetes cluster. I want to show you the big values file that has all of the different options listed. So this is the ingress Nginx GitHub repo, and we'll bump this up a little bit. But these are all of the different possibilities for how you can configure your ingress, your Nginx. Okay, this particular file is 923 lines. So there are a lot of options, and that can be really overwhelming. We're not going to do all that. I have something relatively, at least it has way fewer lines than that set up to go. So I've got this file here. And I have some configurations options.
Fucking stop, you fucking piece of... Okay, chill out. Chill out. Deployment ingress. Nginx values. We're looking at the Nginx values. This is the controller. Hold on. This is the issuer. Okay, start manager, issuer. Let's encrypt Nginx. Backend. Okay. Uh-huh. Private key. Where is it coming from though? Start manager values.yaml. I'm guessing it's coming from this file right here. I would like to see that. Okay, it's not open.
And I have some configurations options set up. And so starting on line 4, I'm just talking about the controller, and this is related to Bleeb's comment. So they say, by default, Nginx gets deployed with one replica. Is it advanced to run multiple replicas for redundancy? Yep, depending on the size of your cluster, you probably want multiple replicas running. And so I'm going to run 2 replicas of my ingress Nginx, and then I'm setting some resource requests. So I'm saying my node that this pod gets installed on needs at least 100 Ms of CPU and 90 megabytes of memory. So very basic, but just putting some constraints on that. So you can see some things I have commented out. We'll be looking at those later. But let's install ingress Nginx in my Kubernetes cluster, and let's pass it this values file to configure it. So there are 2 replicas of ingress Nginx running. All right, so first thing I'm going to do is I'm going to create a namespace, an S for namespace, called ingress-nginx. Well, I didn't do it right, so I have to say create. So cube control, create namespace, ingress Nginx. And if I say cube control get namespaces, we see that namespace there. And now what I'm going to do, I have this command saved, is I'm going to install the ingress Nginx Helm chart, and it gets installed as a release. I'm going to call that release ingress Nginx, and I'm going to pass it my values file. So here's what the command looks like. So you say Helm install, and then the name of your release is next. So I'm calling it ingress Nginx. And then you say which Helm chart you want to get it from. So I'm saying, hey, I want the ingress Nginx Helm chart from the ingress Nginx Helm repository. I'm installing this in the ingress Nginx namespace, and then I'm passing it that file that I just showed you, which is called nginxvalues.yaml. So we'll hit install there. And it might take a little while. Let's see, just scrolling back through the comments. All right, we'll let that install, and we'll just review what are we installing. So what we're doing right now is we're installing the Nginx ingress controller, which is going to be inside the Kubernetes cluster. And the other thing that ingress Nginx is doing automatically is it's creating a load balancer service, which is going to have DigitalOcean create a load balancer. We're going to get a public IP address on that load balancer, and that's where our user traffic is going to go. All right, so this looks like good news. Okay, so we get this this message from Helm. It basically says, hey, I created a Helm release called ingress Nginx. It is deployed, and then the Ingress Nginx team has given us an example ingress that we can use. We'll do that in a few minutes. And then it says, if TLS is enabled for the ingress, a secret containing the certificate and key must also be provided. So we actually are going to do this later. And so we're going to have a secret in the same namespace as whatever service that we're deploying. So beautiful. All right, well, let's take a look in the Ingress Nginx namespace. So kube control, I'm going to get all resources from the namespace Ingress Nginx, and we'll just see what we find. All right, excellent. So there are our 2 replicas of the Ingress Nginx controller that are running. So we have 2 pods running that. So we've got a little bit more availability there. We've got 2 different services that were created. The first one is the load balancer service. And this is really exciting, where it says external IP. DigitalOcean is spinning up their own load balancer right now, and we're going to get an IP address that we can actually access, which is exciting. It takes a few minutes in general for those to be created. We also have this other service, Ingress Nginx controller admission. It's got an IP address that is only available inside the cluster. So that's part of the Ingress Nginx system. Then we have the deployment and replica set. So let's run the command again. Actually, we'll just get services. I want to get the external IP address for my service. Okay, it's still pending. So we'll have to come back to that in just a second. Beautiful. All right. Actually, I don't want to skip that. So let me go to the DigitalOcean Cloud Console. All right. So I'm here. And this is the name of my DigitalOcean Managed Kubernetes cluster, Ingress Nginx demo. And I'm looking for the load balancer, let's see. Okay, let's go to networking, see if we find the load balancer there. Okay, I'm going to go to the load balancer tab. Okay, so this is, it looks like it just turned on. So this is my load balancer. DigitalOcean is managing that. I've got this public IP address. And if I put that address in my browser, this is great news. I'm getting the 404 page from Nginx. So I have this web server up and running. And when I go to that public IP address, something's happening with Nginx. And so what I want to do now is I want to make this IP address work for me. So let's go back, take a look at the agenda. So what we just did was install the Ingress controller inside the cluster. That also created the DigitalOcean load balancer. So now we have a public IP address where we can direct.
Nice collab, yeah.
And so the next thing that I want to do,
I'm just like trying to learn.
Because
this is new.
My DNS. And
the
so
entire Kubernetes is new to me.
Set it up so that DigitalOcean has access to it. And instead of having my users having to type in that IP address, I want to give them a domain where they can type in the address and have access to whatever application's running that way. So let's configure DigitalOcean DNS. So first,
from a viewer's perspective, it looks like you guys are presenting together. Yes, we are. Right, Kim? Yes.
So there are a lot of registrars. Google is one. GoDaddy is another. Namecheap is one. My registrar of choice is name.com.
Here's to you, Kim. Thank you very much
located in Denver, Colorado, and that's where I live. And so I bought this domain from name.com. So the domain is
This section I already know, so I'm just gonna.
I'm back.
I think it says she. I'm not sure, but regardless.
Account down to manage DNS on DigitalOcean.
You know, like telling me like not to interrupt.
I already have 2 other domains here, but I want to be able to manage Cube.
I'm not sure. I didn't really check, but looks like it.
Standing.
Yeah, I can go over this section here.
That's is. So I'm going to direct public
a
new cluster, which is the load balancer in my Kubernetes cluster or outside of my Kubernetes cluster. So the way that I do that is I'm going to, I'm creating a new address record, an A record. I'm going to say quote.
This is the first time I'm watching their video, so honestly, I have no idea.
Because that's the domain that I want to use. And then It's going to direct to which IP address. These are my Kubernetes worker nodes. I don't want, those aren't open to the public, but the IP or the IP address of the load balancer. So I'm going to direct to that load balancer, and I'm going to create.
Oh, hold on, my cat.
A record. I don't know if it's.
One second. You wanna spend time with me, babe? Let's open this door a little bit. Okay, there's a good boy. Come on, get on your cushion, eh? That's a good boy. Come on, babe. Oh, such a good boy. Yeah, you can sit on your cushion right there. Oh, there's my boy. There's my boy.
It's a record, or like the A record was created successfully. But you see here under DNS records that I've got the host name quotes.kubetips.online direct, or like the A record was created successfully.
Okay.
But you see here under DNS records that I've got the host name quotes.kubetips.online directs to the address of my load balancer. So outstanding. I think that might be it. Let me check my notes. Yeah, beautiful. All right, let's go back to the presentation. So where are we? What are we doing? We've created the Ingress Nginx controller. We've created the DigitalOcean load balancer. And then what we just did was we configured DigitalOcean DNS. And so
breadcrumb, what was a mess? Are you talking about your code?
I'm going to deploy this service in my Kubernetes cluster. It's called the quote service.
Trying to get the watchdog working.
Yeah, we're going to create the backend service, and then I'm also going to configure the Nginx ingress rules, but we'll come back to that in just a second. All right. So
did it work?
I want to deploy an application in my cluster. That's the whole point of Kubernetes, is that your deploys that talk. And so, Swami has a good question about the last section. So they say, can we just create the A record in the registrar's DNS portal instead
Seems
of
to be working now?
servers?
Cool, bruh.
You can
Congrats.
do that, especially
good job,
for
man.
what I'm showing you today. When that gets complicated is if you want to use a wildcard certificate. So in order to set up a wildcard certificate using Cert Manager and Let's
Wiper, how we doing, baby? Welcome.
Edit text records from inside the Kubernetes, all of your Kubernetes manifest, and let's just take a look at it. So the manifest contains two YAML specs. One is for a deployment, and one is for a service. And if we look at the deployment,
yeah, that sounds like it should work.
I want one replica to be running
with the
and
watchdog.
It is going to live in the backend namespace. And it's pulling this image to create the container. So this image was created by DataWire, which is now called Ambassador Labs. And it's a nice image. It's like a public API that you can use to practice things in Kubernetes or with containers. And what it does is it just delivers you a JSON object of a random quote.
Cool.
So that's.
Is it gonna be like on your stream when you're streaming? Is it gonna show up there?
Resource requests and limits, best practice in Kubernetes. So we're gonna create one.
Been one of those days when I didn't want to do any work, but I'm going to be updating my CV and actually start applying for jobs now. Hell yeah, bro! Send them out, baby. You got this, man.
Thing that has a stable API, or not a stable API. Let me start that again. In Kubernetes, a service is a thing that has a stable IP address so that when your pods come and go, they're meant to be reusable. They're meant to be spun up and be spun down, and their IP addresses always change. But your service, and that's in the quote directory. Excellent. So I'm quote. I need so since I didn't run.
I'm gonna have it running on the side so I can show what I'm trying to do in tasks. Hell yeah, that sounds cool, bro.
Kube control, apply file.
If it is good to go, if you go online again, I'm gonna check it out and see how it looks.
Deployment. All right, so we're applying that. It's backend of that pod running, and it's here. We have the service, which is also running. It's called quote.
Obsidian.
Here's that stable IP address.
Cool.
So it's going to be
that's
running.
that's the same one you use to update those pictures, right? Like the pictures of the games that you were playing on the NES or something. I'm feeling weird, bro. I'm not like in the zone. What the fuck?
There, we can send traffic there.
It's a brain bank.
Traffic to pods. If we had more than one pod running, the service could load balance over those pods. And then the deployment replica set are just help us determine how many replicas we have running. All right. So actually, that is one of the steps. This is a nice step that doesn't take too long. Let's see. Beautiful. So we just created the backend service. So we've got a check mark over the quote service. In the repo that we shared, they also tell you how to deploy a second service called the Echo service. I'm not going to show you the Echo service today, but feel free to do that. So that's why there's no check mark and there'll be no boxes on that. All right. And so now the next thing that we need to do is we need the ingress controller to know, hey, when do I send traffic to that quote service? And so we're going to configure the ingress rules. So let's see.
Fine. Let's see.
Oh, I'm jumping ahead too far. When we checked for everything running in the backend namespace, we saw a pod and a service. And now we have to create a new object called an ingress. And this is where we're going to configure the rules that tell the ingress controller, hey, when these things are true, you direct traffic to that quote service. So back to the text editor. I've already got this set up, and it's in a file called ingress.yaml. And if we look here, so we're going to create a new Kubernetes resource called an ingress. It's going to be named ingress quote, and it's going to reside in the backend namespace. And we'll talk about these commented out parts in a little bit, but let's look at the rules. This is what we're configuring. So the first thing is we're configuring the host. And in Nginx, host, I think that's an Apache term, but it's used a lot in Nginx. And it's just basically saying like, I would like my server to be able to host multiple domains and like direct traffic based on those domains. And so the host that I'm going to be specifying these rules for are the quotes. And then I've got your domain. So it's quote.
You showed me the silliness. I love the silliness.
And we're saying, hey, when somebody requests that particular domain name, well, the first thing it's going to do is the DNS stuff is going to happen, and it's going to say, here's the IP address. And then once that request gets to the ingress Nginx controller, it's going to say, oh, I have a set of rules for what to do with quote.kubetips.online. And when it's just the base path, I'm going to direct that traffic to the quote service. And I want it to use the port 8080. And I'm doing all of this with the ingress Nginx controller. You can have multiple controllers running in a cluster. And if you have that happening, you want to specify the ingress class name saying like, oh, I want my ingress Nginx to be handling this, or I want my Ambassador Labs ingress to be doing this. So let's see if this works. So I'm going to create this ingress object in the backend namespace.
That's like what I have here for mine, right? In the ingress and Nginx ingress. Yeah, pretty much the same shit. Ingress class name is Nginx, and then rules. This is the host for the API, and then the host for the front end. And they do the same exact thing. And then this one goes to the API service. This one goes to the Next.js service, right? So if it is for Filelib, it sends it to the Next.js container. And then if it is API, it sends it to the API, the Django setup that we have in this one here, which is cool. I really need to be paying closer attention to what you are up to. I need to get good at Kubernetes and all this crap. We're looking to move into this space in the near future. Gotcha. Yeah, I mean, for me with this is like me touching this for the very first time. I've never done this before. I've never touched Kubernetes before. I'm pretty efficient when it comes to Docker. Like I'm able to figure things out and then, like resolve my things in a timely manner. But with Kubernetes, I just didn't have any experience whatsoever. I know that it used Docker containers under the hood, one of the options for containerization models. But again, like I just never done it. But what it offers as a whole, as a tool, right, is the auto scaling up and down. I really, really, really like it because that's definitely what I need. So when my API has a spike, if somebody is hitting like, about 400 or 500 requests per second, I just want to like fire up new pods that handles additional incoming requests. So it doesn't time out or it doesn't die or it doesn't crash. And you are able to do that with Kubernetes. And at other times, it can just sit, on the log level. When there is a high load, it can jump up and down automatically on its own. So that's the reason I wanted to do that. And then now, like what I am looking at here, so I have two host declarations, one for Filelib and then one for the API.filelib. This is my API endpoint. And then for this one here, actually for both of them here, I want to use TLS. So that's the section that she's coming to. So let's go.
Is that, yep, that namespace is specified. So I'm going to say kube control, apply the file in the quote directory, and it's called ingress. Beautiful. And so let's say kube control from the namespace backend, get ingresses. Excellent. And we just see some of that information that we configured in that YAML file. So the name of that ingress is ingress quotes. It's using Nginx. It's the quote.kubetips.online host. No address. Let's see if that changes. Well, it hasn't changed yet. I think that is going to change. All right. So let's see what happens. So first thing we'll try is, can we access quote.kubetips.online from a browser? Let's see.
You can find her browser.
This is always the part of the talk that's embarrassing because I've lost my Windows. There we go. All right. So, okay, if you remember, we typed in the address of our load balancer and we got the Nginx 404 not found page. So if I did quote.kubetips.online, will I get anything? Okay, so I actually got, this is what the quote service gives you. It gives you a random server name and a quote. Abstraction is ever present, which is extremely pertinent for Kubernetes and cloud computing. And then it gives us a timestamp. And Matson, thank you so much. I sometimes don't celebrate. Oh my gosh, you guys, it works. This is so exciting. It asks for this. Chrome is like, your connection to the site isn't secure. When I was and I'm going to say HTTP quote. Oh, and you can go to this site too if you're watching live. I'm not sure. I might pull this down after the talk, but quote.kubetips.online. Oh, okay. All right. So
Hold on. Time to learn. What the fuck does it mean? LI flag, curl, L flag. What's that? To make curl follow a redirect and get the requested resource from the new URL, you can use the L flag as shown above. The flag is often used by developers to get detailed information about how the server processed their request. For example, when from based on data. Okay. Okay, what is the I flag? I flag. It really means that we want to get the HTTP response headers in the output. Once we submit this curl command, document can be in the rename cookies and data document on the HTTP version and even more. Okay. So if I do could not resolve host. Oh shit, what the fuck is this? All right, see, it does, okay, and then if I add What the fuck am I looking at here, bro? Lowercase l versus uppercase L. It gives me the HTML. Oh yeah, it gives me the entire HTML. Yeah, let me learn, curl daddy. Okay, lowercase l, uppercase L. Okay, there you go. So lowercase l is list only mode. Okay, what's that mean? And then L, location, follow redirects. Okay. I, include protocol response headers in the output. Okay, that's basically what it means. Perfect. Yeah, because it's following it and then getting the HTML output of the entire response. That's what we are seeing. And then the lowercase l just shit. What was it? List only. I don't really know what that means, but okay. Just want headers. There you go. So it does like it redirected to home, location home. Perfect. And then 308 permanent redirect. And then this is coming from here. I think it's no. Yeah, it's coming from right here. Yeah, I'm doing a permanent redirect here. Right, redirects, and then if it is directly this, send them to home. Coolios. All right. So I just wanted to like learn what it was before I forgot about it.
HTTP1. Yep, looks good. We're getting.
Yeah, I see that HTTP1, and then transfer encoding chunk, keep it alive, refresh, zero, home. Okay.
Okay, we got a new quote because that was a new request.
That's the response.
You read is often.
Oh, I'm sorry, baby. Didn't mean to scare you, big boy.
So Jimmy says you might be able to get certificate information in the Learn More section. So not secure, Learn More. Okay. So a certificate from a certificate authority saying like, hey, I can verify that Kim owns that domain, and so you don't have to worry too much about her trying to trick you. So let's figure that out. So we'll close out some of these tabs. We'll see where we're at and keep going. Okay. So the green check marks are all the things that we've got set up. And here's what's to come. So what we're going to do next is we are going to install the Cert Manager project. And Cert Manager is a lot of software that helps you provision certificates inside your Kubernetes cluster. And think back to when we installed, I guess it was Ingress Nginx. The Helm chart gave us some tips. They were like, hey, you need to create an ingress and configure those rules. And then you need a secret containing like a certificate somewhere in your cluster. So Cert Manager is going to help us do all of that. Cert Manager works with lots of different projects. We're going to be using Let's Encrypt to be our certificate authority because it's a wonderful nonprofit that generates certificates for you for free. And then you can also set up Cert Manager and Let's Encrypt to renew your certificates automatically so you don't have to remember it, which is wonderful. And then using Cert Manager and Let's Encrypt, we're going to, put production TLS certificate. It's going to be stored inside the cluster as
all right.
a secret. And so we'll take a look at that. All right, so our next step is to configure the TLS certificate. And as you just saw, there's like 3 different things that are working. Ooh, I got a good tip from Luca. They said, you need to specify HTTPS to see the certificate. Let's try that. Thank you, Luca. So if I say HTTPS, quote, oh, that's a different domain I was using to practice. So quote.kubetl tips.online. Aha, love it. Thank you, Luke. I appreciate the help. Okay, so this is just what I wanted to show you. Chrome was like, nope, this isn't safe. And if you go up here, it says the certificate is not valid. And then I wish I could I wish I could make this bigger, but I don't think I can. It just says Kubernetes ingress controller fake certificate, which is not a real certificate. So it's a self-signed certificate that got generated with Ingress Nginx, and you can look at the details here. Kubernetes Ingress controller fake certificate.
So if I do this here, I'm guessing this is... Oh shit. So it does have one, but because... What the fuck? Yeah, it still works. Jesus Christ. All right. I did not know that it actually like provided the fake one off the bat.
Here is the fake certificate that your browser will not like. So we want to change that. We want to have a real certificate from the certificate authority. Let's encrypt. All right. So first thing we need to do is we need to install the Cert Manager Helm chart in our cluster. And so let's go back to Artifact Hub and let's find Cert Manager. And like before, there are multiple...
I'm gonna piss before this happens. Give me a sec. Coco, baby, it's okay. I'm just getting up. I'm sorry, babe. Oh, I'm sorry, my fluffy baby boy, Mr. Kid. Okay. I am back, big boy. This good boy. Coco's good boy. This my kitty. Such cool kitty. It's a cool kitty.
Published Helm charts called Cert Manager, but we want the official one, which this is nice. There's this tag here that says official, and then the org is cert manager. All right. And let's just see what the very high level description of cert manager is. It says cert manager is a Kubernetes add-on to automate the management and issuance of TLS certificates from various issuing sources.
Okay. Artifact hub. What the? Did you just close my fucking tab? Oh my god, what the fuck happened? I just tried to open up a new tab.
Upgrade, so you can plan accordingly.
Oh, this is so fucking annoying, bro.
Which this is
thank
nice.
God it fucking remembers. Fucking dingleberry fuck. This is the one that says official, yeah. Okay, cert manager is a Kubernetes add-on to automate the management and issuance of TLS certificates from various issuing sources. It will ensure the certificates are valid and up to date periodically and attempt to renew certificates at an appropriate time before expiry. Prerequisites: Kubernetes 120 plus, installing the chart for functional instruction, including details on how to configure extra functionality in cert manager can be found in installation docs. I think this was the one I was looking at. No, motherfucker, I'm trying to see it. You motherfucker. Why? Why would you do that? Ding-a-ling. Okay. Let's
There's
continue.
this tag here that says official, and then the org is cert manager. All right. And let's just see what the very high level description of cert manager is. It says cert manager is a Kubernetes add-on to automate the management and issuance of TLS certificates from various issuing sources. It will ensure certificates are valid and up to date periodically and attempt to renew certificates at an appropriate time before they expire. Wonderful. Love that sort of automation. All right, so we've got information about how to install the chart. Okay, so there are two options. It's not two options. There are two steps. The first thing we have to do is we have to install the cert manager custom resource definitions. And so we need to have some cert manager Kubernetes objects that we interact with. And the way that you do that is you run this command. And last night I was practicing for the talk and I kept not running this command, but installing the Helm chart. And then I kept encountering errors because Cert Manager was asking for resources that didn't exist in my cluster. So this step is pretty important. And you can see I created a certificate request. Actually, let's just look. Kube control, get CRDs. And then things that Cert Manager installed end with cert-manager.io. So we created a new object called a certificate request. We'll look at that. The actual certificate, that's the thing that we saw in that diagram. There's an Acme challenge to make sure that certificate that Let's Encrypt can actually verify that you own your domain. And then we have Cilium stuff. And then we have cluster issuers and orders. So we'll take a look at all those things in just a couple of minutes. And the next thing that I want to do is I need to add the JetStack Helm repository to my Helm instance. And so let's just copy this in here. And I'm saying Helm repo.
Okay, hold on. Minikube Helm. Minikube. Using the Helm Minikube add-on. Because when I do Helm, where the fuck did I run it? Okay, let's see what the fuck is happening here. Let's do Minikube. Problem with running. How can I get access? Okay, so this is. It's even worse. key. Okay, it's okay. All right. It's all right. All right. All right. Let's continue.
Oh, add JetStack. Excellent. And if I say Helm repo, list all of the repos that I have. There's JetStack at the bottom, and let's update that. Just to be safe, Helm repo update JetStack. Excellent, looking good. And then I'm going to do the Helm installation, but like Ingress and Nginx, I want some custom values passed in through a file. And so this is called cert manager values, and this is a very pithy 8 lines. So I want to install the CRDs. I already did that manually, but we can leave this here. It won't do anything. Just check if it's done. And then if I want to monitor cert manager activity by scraping Prometheus metrics, I would enable that. I'm not doing that right now. So it is listed as false. All right. I need a big, long command, which I have in my notes. First thing, create a namespace, kubectl create namespace cert manager, so we can have all that stuff in one place. And then I'm going to install cert manager. And so I used version 171 to install the custom resource definitions. You really want to make sure that you have the same version using your Helm chart. So I'm going to specify that version number. So you can see I've got Helm installed. The release name is cert manager. In the namespace cert manager, version 171 from the JetStack repository cert manager. And then please use the cert manager values. So we'll hit install there. And we'll let that go. Oh, installation failed. It says rendered manifest contain a resource that already exists. I was wrong. Let's change this to false. So since I installed the CRDs using that kubectl apply command, I think that's why it's erroring out. So let's try that again. Oh, that didn't help at all. Okay, well, all right, while we're waiting, let's go back and just take a look at what we're up to. And so what we're doing right now is installing Cert Manager. Created a Cert Manager namespace, added the CRDs, and then now we're installing the Helm charts. Excellent. This is the thing I want to see. It's that Helm message. Hey, I deployed Cert Manager. Gives me some instructions. In order to begin issuing certificates, you will need to set up a cluster issuer or issuer resource. More information on the different types of issuers and how to configure them can be found in our documentation. So let's go to the documentation and see what we find. All right, so there are different ways of having certificates issued using Cert Manager. You can do self-sign, a certificate authority. You can use HashiCorp Vault, Venafi, External, and Acme. We're using, I believe, the CA. Actually, no, we're using, we're using CA. We're using Let's Encrypt as the CA. This isn't quite what I wanted to show you. I already have the tab open. This is what I wanted to show you. So this is the Cert Manager docs, and it's just showing you sort of how the project works. So you have Cert Manager, and then you choose an issuer. So like I said, you can use Venafi, you can use HashiCorp Vault. We're going to be using Let's Encrypt. Let's Encrypt is wonderful. They have 2 servers where you can send requests to get certificate. One is a staging server. So in your staging environment, if you want to make sure that you've got things configured properly to get a certificate, you can make requests against their staging server. They also have a production server where you get those real certificates. So outstanding. What we're going to do is we're going to be using the Let's Encrypt prod server. And then Cert Manager creates the actual certificate inside of your Kubernetes cluster. And so like this example here. And then the signed key pair is stored as a Kubernetes secret. All right. So we have installed Cert Manager. Now we want to tell Cert Manager to use Let's Encrypt as the issuer so it can give us a production TLS certificate. So back here, we have our issuer.yaml file. I'm going to get rid of that at the top. And so this is a Kubernetes resource, one of those custom resources that Cert Manager created. So it's this kind issuer. There are two kinds of issuers. There's an issuer which is bound by a namespace. So if you want to create certificates for something in one namespace, use an issuer. There's also something called a cluster issuer, where if you want any namespace to have access to that certificate, I would use that one. We're going to use the issuer just to keep it simple and straightforward. The issuer, we're going to call it Let's Encrypt Nginx. If you are doing that thing where you have a staging and then a production issuer, you can say Let's Encrypt Staging, Let's Encrypt Prod. I mean, you can name this whatever you want, but we're going to keep it as is. Let's encrypt Nginx. And this issuer is going to be working in the backend namespace. Remember, that's where the quote service is deployed. And then some nice documentation in here. So first thing is we have to give Let's Encrypt a valid email. So my work email is kschlesinger@digitalocean.com. And then you say which Let's Encrypt server you're making those requests to. This is the URL for the production server. I believe it's like staging for the other one. So we'll just leave that as is. And then private key secret ref. We want to create that signed key pair as a secret called Let's Encrypt Nginx private key. And then how is Let's Encrypt going to verify that I own this domain? We're going to use the HTTP 01 challenge. And so when I spin this up, Cert Manager, Let's Encrypt, it's somewhere going to create an HTTP endpoint from inside the cluster that it can then ping, and then it can say like, oh, because I was able to create this endpoint and I can access it, that must mean you own this domain. Cool, here's a certificate. All right, so there's a lot of words. Let's just apply this. Cube control, apply, file, issuer. And as we do this, we're going to look at all of those different Cert Manager. Sorry, I got distracted. We're going to look at all those custom resources that Cert Manager created. So
Yeah,
Felipe has a great question. Will the files be available after this presentation? All the files are actually already available in that starter kit link that we posted at the beginning. We'll post it again right now. But yes, they're available right now for you. So go ahead and take a... Actually, why am I just saying it? I'm just going to show you. I'm sorry. Okay. So this is the starter kit. And this thing has so much good information in it. We just posted the link here. Thank you so much. And we're working through 03 setup ingress controller. And so for the specific files for ingress Nginx,
Kubernetes starter kit, developers 03 setup ingress controller 03, this one right here. So it is like, where is the fucking thing coming from? Search manager issuer YAML. This is the one, right? So Private key secret ref. Where is this coming from? This. Set up ingress controller. So where is this secret coming from? It's
Go
like
to assets.
Okay.
And then manifests. And you'll see like the ingress or the Nginx values, the cert manager values, and then Nginx, all of the stuff is in here. So let's see, like the quote host, that's what I call the issuer. No, that's the ingress. Let's see. Nginx. What did I just make? I made the issuer. Oh, cert manager issuer. Yep. All right, here. Yes, I'm so glad you like this repo, Jimmy. We've spent all go back. Now we kind of want to see, how does cert manager work? How does it talk to Let's Encrypt? How does Let's Encrypt generate that certificate? So first thing I'm going to do is I just want to look at the secrets in the backend namespace. So Q control get secrets namespace backend. Interesting. All right. So you can see 2 minutes and 5 seconds ago, when I ran that command, I created this Let's Encrypt Nginx private key. So we have like the private key stored in this backend namespace, which we saw instructions telling us to do that a lot. We'll come back to this in a couple of minutes. But kube control get CRDs, and I'm going to grep on cert manager. I just want to inspect like what's going on. So let's see. The first thing is, let's see what is a cert manager order. So kube control get order from the namespace cert manager. Oops, wrong namespace. It's in the backend namespace. Oh, okay. It looks like I don't have any orders going, so maybe the certificate already was issued. But let's look at the, we can come back to that. Let's look at the issuer. So let's see. I like having my namespace up front in the command, so then when I go up, I can just add to the end. So kube control namespace backend get issuer. All right, so I have the Let's Encrypt Nginx issuer. So this is the object that says like, hey, make your certificate requests against the Let's Encrypt API. So that looks like it's up and running. We shouldn't have any cluster issuers because I specified an issuer, not a cluster issuer. Let's look at challenges and see if maybe that HTTP01 challenge is working. Get challenges. Nope, doesn't look like it. Uh-oh, I'm feeling a little nervous. Like maybe I didn't do something right, but that's okay. Let's look at certificate requests. See if we have a request for a certificate up and running. Nope. And then, all right, let's see. Do we have a certificate? Maybe it happened really fast. Get certificate. No. All right. That is making me nervous. So I was expecting to see an order. The order is the thing that says like, okay, I'm going to make a challenge against with Let's Encrypt, and we're gonna that endpoint that you see if I maybe didn't do something. All right. We'll actually go to the starter kit. So we're doing Nginx, and I am configuring production ready TLS certificates. Okay. Cert manager values. I think I did pass that in. And then I've got cert manager. Okay. We've got all that stuff from cert manager. We looked at the custom resource definitions. Did I apply the issuer? Did I change the ingress? That's a good question. Oh, I don't think I have done that yet. first of all, let me just make sure I have an issuer. Okay, let me clear this out. Cube control issuer from all namespaces. Yeah, I already checked this. I have that Let's Encrypt Nginx. Beautiful. Okay. You need to configure the ingress Nginx to use TLS. Yep, I think Bleeb84 is right. All right, so I created an issuer, but now I need to reconfigure my ingress so that it knows to use Let's Encrypt Nginx as the cert manager. So back to this, back to my ingress. And so I already have these things in here. I have to add an annotation to this ingress that's just says certmanager.io, and the issuer is Let's Encrypt Nginx. It's got to match the name here. So those look good. And then I need to add this block of TLS configuration, hosts, so quote, and it is kubetips.online. All right, and let's apply that. Cube control, apply file, quote, and then that is called ingress. All right, so it looks like it updated that. And so now cube control namespace backend. I'm curious if I have any orders. Aha! Thank you, Bleeb84. All right, so now I have this order that says it is pending. So cert manager is saying, hello, I would like a certificate for this quote host. And then I'm going to look at, let's see, we got issuer order. Let's look at certificate request. So we've made a request for a certificate. This takes a few minutes. So it says it's approved. Oh, it says it's ready. Maybe it's all ready. All right, let's see if we've got a certificate in the backend namespace. Wow, that happened so fast. All right, here is the big trial. Hey, all right. So Matson is right. It works. So if I use HTTPS, I see this has a valid certificate. And if I go to connection is secure, certificate is valid. So before, the certificate was like, what was it called? Like Kubernetes dummy certificate. This says, hey, here's your certificate. It's valid. And if we go to details, we'll see that the issuer is Let's Encrypt, and we've got all this information here. So nice. So now we've got, we've got like a nice secure website.
All right, I'm gonna go use the restroom. I'll be back. Alrighty, let's continue.
Site that we can feel good about sending customers to. So yes, this is so exciting. All right. Well, if we take a look here, we installed Cert Manager. We set up Cert Manager to use Let's Encrypt as the issuer, and then we have a production TLS certificate. Let's look again at, sorry, let me clear this. Cube control, get secrets from the backend namespace. So we have two secrets here. We have the private key, but we actually have like the TLS certificate stored as a secret here. And so Cert Manager and Let's Encrypt work together to put that here. So that is, let's see, go to my browser. So that's the production TLS certificate living as a Kubernetes secret in the cluster. Awesome. So we've done all of this, and there is one more thing that we need to do, and that is to enable proxy protocol. And there's no part of the diagram for this. And so basically what happens is because we have that DigitalOcean load balancer with its IP address, the traffic is hitting that load balancer, and then the load balancer is forwarding the traffic to the ingress controller. If we want to get client IP addresses for logging purposes or that our application needs, it's all going to be the same address of the DigitalOcean load balancer. And what we want instead is we want to know what is the actual IP address of the person or machine that made that request. And so in order to do that, we enable proxy protocol. And so we need to go back to our ingress Nginx values. And there's two things that we need to do. Let's see. I need to, let's see. That's not working the way I wanted it to. I'm going to uncomment out these things. And so this is for the load balancer that ingress Nginx spun up. I'm saying enable proxy protocol, true. And then this says specify whether the DigitalOcean load balancer should pass encrypted data to backend droplets. So I'm going to say, yes, I want that encrypted data to come through. And then the last thing is I want to set these configuration options. So use proxy protocol is the only thing that I care about right now, but I'm going to uncomment these as well, just adding to the Nginx config. So all right, I'm going to, let's see. Yeah. Okay, so since I installed ingress Nginx using Helm, I need to update my Helm release using Helm. And so the way I'm going to do that is instead of Helm create, it's going to be Helm upgrade, and I'm passing in that values file. Uh-oh, I think I missed the most important part, which is to show you how that works. So let me see if I can curl before this changes. Quote.kubetips.online. All right. So that was my request. You see this come back, and okay, so it looks like that ingress Nginx has been updated. So we'll run that command again. Xage. I'm not sure I'm going to be able to show you any difference here, unfortunately. But that's all right. So I've enabled proxy protocol. It's a little more invisible than some of the other things. All right, so back to presentation. We're nearing the end here. So we enabled proxy protocol. So look at all those green check marks. Look at us. Thanks for hanging with me.
Where's A? Okay, let's play this tune. Okay. We're gonna do this. Okay. Okay. Harputter. Let's go. I feel like it would be helpful to play another one. Where the hell was I? Deploy Nginx Ingress controller. Okay, I already done that, so I think I'm good. But yeah, this I cannot install because I think Minikube already installed it. So can you do like help and then just like Minikube add-ons? Okay. Just so I can try to install it with Helm. Okay, something different is happening this time. Holy shit. Okay, so that was happening because of Minikube. Can you do like Helm uninstall? Aliases uninstall, delete, IU and description string, a custom dry run help, global flags, burst debug. Hmm. Hmm. Oh shit, it's already gone. Okay, my ingress still works, which is good. Okay. I think this is what matters here. I just don't want to do this here. This is the example service. We do. Your service may have its own chart, or you may be deploying it directly with manifest. The quick uses manifest create and expose a sample service. The example service uses card, a demo application. Okay, so we do have a deployment, but I don't know. Do I? Actually, no, I don't. And this is the service. Yeah, this is gonna be like for my Next.js and API. I already have those in place. You can create, download, reference these files locally. You can create them from the GitHub sources. Okay, this is one. Introduce sources of Kubernetes. Okay, ingress class name. Okay. This one right here. We need to install Cert Manager to do the work with Kubernetes to request a certificate and respond to the challenge to validate it. We can use Helm or plain Kubernetes manifest to install Cert Manager. Since we installed Helm earlier, we'll assume you want to use Helm. Follow the Helm guide for other methods. Read the installation documentation for Cert Manager. Helm guide. Okay, so we need this apparently. Okay. Helm repo update. Okay. Cert Manager requires a number of CRD resources which can be installed manually using kubectl or using the install CRDs option when installing the Helm chart. Both options are described below and will achieve the same result but with varying consequences. You should consult the circumstances section below for detail. Okay. Recommended for production installations. It's my boy. It's a good kitty. Such a good kitty. Look at this boy. Look at this boy. He likes to scratch his Mr. Kitty. Yeah. Oh, it's my boy. Oh, it's a good kitty. Oh, it's a good boy. Oh, look at baby. How the fuck do you do this? Like with. Yeah, opening this thing fucking downloads the file. Look, I don't want to download it, bro. Is it the same shit? Motherfucker. This is a lot of stuff. Oi, oi, look at this boy. He's a good boy. What are they doing, eh? Huh? Come here. Come here. Where's my boy? Come here, baby. Oh, look at this kitty. Uh, uh, Come here. You are behind the microphone. You are behind the microphone, big boy. Yeah. He headbutts my microphone. Oh, you my boy, kata kata. Oh, this my boy. You're biting my hand. Ah. He's like so gentle, like trying to hold my hand. Oh, you're a good boy. Yes, good boy. Coco, you want kibbles? You want kibbles, Coco? Huh? Is that what Coco wants? Huh? Coco wants kibbles. Okay, let's eat some kibbles. That's enough. I'm gonna give you dinner like in 30 minutes. Huh? That's enough, eh? You can't be eating all the kibbles, eh? Oh, come here, babe. It's my boy. Yes, my boy. It's my kitty cat. You want to get down? All right. There you go. Oh, I got you. There. Go ahead. Go live your life. Be free. Coco. All right, let's see. There's got to be another one over here. This is the one we watched. Mm. 30 minutes. We can see this.
My name is Stefan, and today's topic actually got requested from someone from our little community. So the question was, how do I enable HTTPS for my website or my API, whatever application is running on your Kubernetes cluster? And a little theory maybe beforehand, you may have heard about SSL, so the Secure Socket Layer Protocol, which is now outdated. So there's a new one, it's called TLS. It's a Transport Layer Security Protocol, and these protocols actually add a security layer on top of your HTTP connection. So they wrap around the HTTP server. Needs to have a certificate, a warning page, trusted, top left, but an HTTP here nowadays. Application we will run on our K3s cluster. K3s cluster on your own and the engine on. Welcome back. So if you want to follow along, then you need to set up a K3s cluster on your own and the Nginx as an ingress controller.
He's saying K8s, like it's just weirding me out.
As I said in the beginning, in the intro, I did already a video about this. It will be linked in the top right corner right now.
The whole HTTPS certification thing is a joke?
Video description
What?
down below. So you can go there first, set up the cluster.
What are you talking about?
And then you can come back and can follow along. Or if you don't want to follow along and just want to watch the video, of course, you can just stay here and watch the hands-on tutorial. Okay, we have our cluster set up. We have our Nginx ingress controller, as you can see here in the top right corner of my page, of my screen. And you can see that I have Linode, a VM, by using the Linode cloud provider already set up. And I just installed K3s onto it. What we also need is this little repository here. So this will be also linked in the video description down below. And you will find all resources I will use in this video in this GitLab repository. So you can just clone it and then use it on your own and you will be fine. On top of this, we need to install this certificate manager. This certificate manager is kind of an add-on like the Nginx ingress controller.
More the process of getting a domain secure, not the HTTPS technology, more that you can put the most malicious sites out there through HTTPS.
Certificate we will request. So we want to obtain a certificate. So
I see your point now. Okay, yeah. I mean, like with like anything out there, you know, if you have the ill intentions, it doesn't matter that like you are using a TLS on your domain. It's just whether or not what you are serving to your users with that. The thing with the TLS certificates right now, or SSL certificates right now, is, you know, it requires an email address and a first name, last name, which you can practically get from anywhere. It doesn't really, like if you are doing Let's Encrypt, the amount of information it's asking is that you have to have a domain name, yes. And then you have to have an email address, yes. And whatever name you pass, it doesn't matter. And for the, I think what kind of gets offloaded is the verification. If you're trying to identify someone like that's doing like harm through their websites, is that like whoever owns the domain name, you know, like it requires like a lot of personal information to acquire a domain name. So by verifying ownership of the domain name while you are acquiring an, you know, SSL certificate, the issuer there is offloading it to the registrar, the domain registrar. So, but again, like you can even fake that. Like it's not like they are really doing like an ID check when you are signing up and registering a domain. I'm pretty sure I could use Namecheap with a Visa gift card. Yeah, that's what I'm saying. Like you can fake the entire process. Like it doesn't stop people from, you know, like faking information while acquiring a domain name. And I'm guessing there are like even like more looser registrars out there that doesn't really like give too much, you know, focus on verifying identity. Like I have like a lot of domain names, like over 30 at this point, and then like not a single one of them like asked me to prove my identification. But because I'm not doing anything, you know, like malicious there, like I use my actual credit card and whatnot to pay for the service. But like you said, you can use a Visa gift card and you can put any fucking name there. It's like, it's arbitrary. So, yeah.
So we need to do
If you really
some
want it,
configuration work.
you can.
We will configure cert manager to speak with let's certificate authority, and what do you need to do actually to get a valid certificate is that you need to prove that you are the owner of that domain, that you are the owner of the server and the domain you want to obtain the certificate for. And we will use this in our K3S.
So I think I would prefer that this would be via, okay, hold on. kubectl, let's encrypt DNS challenge. Like, this is what I want. I think this would be like so much better. So it looks like it exists. Fucking motherfucks, bro. Okay, solvers, DNS. So that's kind of like what I want. Let's go do like search. Okay. Okay, so they do have it. Cool. Cool. This is cool. I still want to watch this video. Let's see.
Cluster so that we can encrypt, and so how you can use that certificate. You then need to apply the deployment and the server, but afterwards demo application. We can also take a look at this. You will see that there's nothing special in here. So it's just 3 replicas of this demo application here. And for the service part, it's as well a really easy service YAML. It's just listening on port 80 and doing. We need to obtain certificates. We need to have a valid DNS, or from the perspective of Kubernetes, we need to have a valid DNS. So maybe if you want to follow along, you only have the IP address. Maybe you also have a domain address. You need to the as we actually with .io, and we should see something. Okay, we on advanced in the free. Yeah, you can see this here by looking at the free cows, light blue. This is not certificate installation, and then just grab the first line you will be offered for the static install, copy paste it here, hit enter, and this may take like 30 seconds or something.
Okay. So I don't really need Helm to do that, like to install it specifically. I can just do it directly with the thing. Okay. Because this is what I'm going to need when I'm doing it with the GitHub Actions.
With Let's Encrypt. That's the first step. Issuers, we need to define. I have 2 of them. One is a production issuer and one is the staging issuer. More on that in a second. Let's take with the certificate manager, we installed some custom resources clusterable through all your namespaces, or just limit to 1 namespace in your Kubernetes cluster. So we will take the cluster issuer. And then there's 2 important parts. One part is the ACME part. ACME is the protocol which is used to obtain certificates.
Okay, so Because I'm not doing it directly on the server, I want it to be done locally, like through the DNS. Yeah. Oh, there you go. DNS, Acme DNS. Cool. Host, acme.example.com. Alrighty. Name, Acme DNS. Key, acmedns.json. I don't really know what this is. Okay, in general, clients DNS perform registration on the user's behalf and inform them of the CNAME entries they must create. This is not possible in certain measures, non-interactive system. Registration must be carried out beforehand, and the resulting credentials JSON uploaded to the cluster is a secret. In this example, we use curl and API endpoints directly. Information about setting up and configuring DNS is available on the product page. Then a server. This example, there is one running at. I don't fucking get this shit, bro. All right, because I'm gonna check my food and then I'll be back. It's almost 6 o'clock and then the food has been cooking. So let's let this continue. Music and then Gökay! Yo! Abi selam. Kolay gelsin. Teşekkürler. Thank you. How you doing, man? It's been a while. Afiyet olsun. Hell yeah. Thanks, man. Appreciate it. How you been? Tutmayayım abi seni sağ ol. I'm just gonna check on my food. I'll be back in a second. I'm not gonna be gone so long. Don't worry. Yeah. Give me a sec. Woo! Yeah, my food is ready. It smells so good, looks so good, and baby, tastes good. All right, I'm gonna get myself a plate and then I'll be back. Okay, so I'm gonna keep playing this video. I think it was this one over here while I
you need to
eat.
provide something there. You need to provide the server, which will actually give you the certificate, where you can request it, where you make the exchanges which are important, that you at the end up with a valid certificate. I will not go too much into detail here, because there's like million pages in the World Wide Web who will explain how you can obtain certificates, and theory based. This is more like a hands-on tutorial, but maybe I will make kind of a short theory video about this. Yeah, maybe in a week or something, so I can link this here as well. So we will link to, or we will point to a server from Let's Encrypt, and that's the staging server. You need to put in an email address. Something like example.com will not work. So put in your real email address if it's a production server, because if your certificate is about to
He froze. Expire.
If your certificate is about to expire, then you will receive an email as well. And those information will be stored in a secret. This is the name of the secret. And then there's the important part of the solvers. So what is a solver? Certificate manager, the issuer, will listen to all ingresses of class Nginx, because we have an Nginx controller. It makes sense that it listens to all ingresses which have the ingress class Nginx. And as a solver, we use HTTP 01. This is a challenge, called a challenge. A challenge which is necessary to prove that you are the owner of the domain and the owner of the server. There's also a DNS challenge, which is a little bit more complicated, and you can almost do the same with both, but you are limited in the HTTP challenge. You cannot get certificates with a wildcard. So if you want to have something like, if you want to have a valid certificate for star.example.com, for example, this can only be done if you have, if you use the DNS challenge. But this is not part of this video, maybe like an extended one in the future, but I will use the HTTP challenge, where you need to point either exactly to example.com or foo.example.com or bar.example.com, something like this. Okay, so let us insert our email here. I know. That will be info at valorcity.com. Save it, and we will do the same for the cluster issuer production. Oops, production YAML. And as you can see, there is a difference in the server URL. Here's no staging, yeah, like here. Why is that? You have two different endpoints for Let's Encrypt. One is staging. You will get a certificate, which will also give you a warning, but it's actually issued for your domain. And the other one is a production certificate, which will leave or give you the gray log on top of the page or in the top left corner. Valid certificate, no warning at all fine. So why don't we use the production one all the time? Because it's a non-profit organization, so Let's Encrypt is a non-profit organization, you are limited for the production API to obtain, I think, like 5 or maybe 10 certificates per day. And if you mess up your configuration, you can reach that limit pretty fast, and you don't want to run into this limit if you are really a production user. So if you have an application which is production ready, because ending up with a invalid certificate is kind of, it's not that good. Let's put it this way. Okay, so we set both configurations up, a production one and a staging. Okay, so we can apply them. Oops. Cluster staging, and we can do the same with cluster issuer and then production. We can also check if they are available by kubectl get cluster issuer, and both of them are true. So this worked. Our configuration seems to be good. So the next step is to actually grab a certificate. For this, we also need, again, to apply a resource. The resource, again, is two of them are in the repository. One is a staging one production one. And if we take a look here, it does not look complicated. So it's a certificate we want to obtain. We need to specify a secret name for this. The secret will store the private key and the public key. That's like TLS or certificate works for web servers. You need both of them. And then there's if a user jumps to your or wants to connect to your server, there's an exchange of their public key and this public key, and then there's a secure connection afterwards. So that's like really broken down to one sentence. There's a lot of exchanging stuff at the beginning, but whatever, in this secret, there's a TLS key and the public one and the private one. And we need to...
Let's Encrypt is a certificate authority that provides free created to do this by connecting to manager, run the tests. We create an issuer, action server, specifies an email address for notifications, as you might iron out all of the testing IP address where or router, and also potentially do port forwarding to your ingress controller's IP address. In order for you to solve the HTTP challenge, your ingress controller must be accessible via the public IP address you configured in the DNSA record.
I really want to do the DNS one because
certificate issuers as a custom resource types in the Kubernetes cluster. It simplifies the process of obtaining, renewing secret that lets encrypt issuer to secure your ingress. When you apply the cert manager, it is specific and must be used to obtain certificates in the same namespace to the cert and adapt certificates and expiration dates in the dashboard. You can renew self-signed certificate that issue other certificates. In other words, to bootstrap. Third example, we would need host names, and the only way to get certificates for them is to use your own CA and issue certificates. You may think that it's secure enough to keep them with plain HTTP on a private subnet. But in this example, I'll show you what can happen in the case of man-in-the-middle attack. We will use Wireshark to capture raw TCP packets between the Grafana and us. We will create a capture filter to only watch for post requests to Grafana and update the credentials, username and a password. After that, we will secure Grafana ingress with a certificate that will be issued from the same Let's Encrypt issuer that will use the DNS01 challenge. Here I'll show you how to transfer the subdomain to Route 53, in my case the monitoring subdomain. To follow along, you would need a Kubernetes cluster. You can easily create one using EKSCTL tool and myconfig. By the way, all the commands that I run in the video and the source code are available in my GitHub repository. First, let's check if we can connect to our cluster. It's a standard check that returns the Kubernetes API service in the default namespace. I'm trying to make all my videos self-contained, that you would have all the components needed for the following examples. Most of the cloud-native services, such as Cert Manager, Nginx Ingress, and other expose metrics in the Prometheus format. Where I can, I try to use those metrics in my videos and create Grafana dashboards for them. This video is no exception, and we will need to deploy the Prometheus to our cluster. If you want to learn more about Prometheus, you should watch another video how to install Prometheus on Kubernetes cluster. Let's quickly deploy Prometheus. We have CRUDs folder with custom resource definitions. Then we have Prometheus operator that will monitor those CRUDs and create corresponding objects in Kubernetes. And finally, we have Prometheus.
Which one is it he's doing? They're just numbered like this is nuts.
Prometheus object to create Prometheus instance. Here are few important configurations. Prometheus will watch service monitor objects with the label Prometheus equal to less than 83. By default, Prometheus will only detect those service monitor objects in its own namespace, in this case monitoring. We can instruct Prometheus to select service monitor objects in all namespaces with the label monitoring equal to Prometheus. We need it since the Cert Manager Helm chart will create a service monitor object in the Cert Manager namespace. Now let's go to the terminal and apply those folders one by one. First, let's create custom resource definitions for Prometheus operator. Then let's deploy Prometheus operator with its airbag policies. And finally, the Prometheus itself. Prometheus operator will convert Prometheus custom resource into stateful set and a config map. Now let's make sure that Prometheus is ready before we can continue. The next step, YAML. Then you can generate YAML files and apply them, or just override default Helm variables and install it using Helm. Let's see what default variables are in the Cert Manager Helm chart. You can find it in the Jetstack Cert Manager GitHub repo. We're going to override a few of them. I assume you already have Helm CLI installed. Let's add that Helm chart repository. Let's search to see what versions are available right now. This is one of those tutorials where you want to install the same versions first. We have a lot of moving parts, Nginx Ingress, Kubernetes versions and Cert Manager. Let's use the 1.5.3 version, which is the latest one at this moment. Create Cert Manager values.yaml file to customize the Helm chart deployment. First, we need to enable CRUDs. Helm chart will create the following custom resource definitions: issuer, cluster issuer, certificate, certificate request, order, and a challenge. Then let's enable Prometheus metrics and create a service monitor object. This label has to match to the one on the Prometheus object. This Helm chart will take the Prometheus instance key and convert it to simply Prometheus. We're going to add a few more later when we get to example 5. Now you can optionally generate YAML files by using the Helm template command. Provide release name, chart name, namespace where you want to deploy it, version of the chart, the path to the values that you want to override, and the output directory. Let's see what we got. All the files will be placed in the Helm generated YAML folder. For example, the cluster resource namespace flag will specify the namespace where the Kubernetes secrets will be created when you use cluster issuer instead of issuer. When you deploy the Helm chart to the namespace that doesn't exist yet, you can use the create namespace flag. For this example, we want to create a namespace ahead of time. We need a Cert Manager namespace to have monitoring equal to the Prometheus label in order to Prometheus select the service monitor object. Go ahead and create a namespace first.
I am not following this at all.
Now let's use the Helm install instead of the template and provide similar flags. This will to indicate that we want to create a certificate authority type issuer, you just need to specify the CA key and provide the path to the Kubernetes secret. Since it's a cluster issuer, that secret must be located in the same namespace where we deployed Cert Manager. This can be modified with a cluster resource namespace flag. This secret developed by example IO key pair was generated in the first example. Here I want to create a certificate in another namespace. Let's create a new one and call it staging. Example to false. Use that magic number here. Then you can define when the cert has to be renewed, the common name on the certificate, and a list of DNS names that you want this certificate for. This field will be translated to subject alternative name on the certificate, Kubernetes secret to store key pair, algorithm for the certificate, finally cluster issuer which is based on our CA. Let's apply all of them. list certificates in the staging namespace. If the status is ready, means the key pair was generated and stored in the Kubernetes secret. The secret name is block develops by example IO key pair. CA. The difference here now TLS cert and CA cert is different. In this video, we will quickly override few watch Nginx in Gravity and 0.1 version. Also, the third deployable video
I'm trying to see the DNS validation that it
username and
does.
password encoded in base60 key that will be you can predefine it in the YAML. Since Prometheus is a dashboard to discover our dashboard.
Yeah, I'm not following this tutorial at all. There's a DNS challenge one here, but I'm gonna go get more food and then we're gonna continue. Let's go. Okay, let's watch this guy.
Do our security certificate here. Mine has run out, and I kind of did it on purpose. I deleted it, and I'm gonna add a new one. I want to show you how to do it. So first of all, you need access to your DNS zone editor. If you don't have that for your website, then this is not for you. You need to do something else. So that's number one. Number two, we're gonna add. We're gonna use Let's Encrypt. And you have to add this Acme challenge here, and right now it just says blah. It says nothing, and we are gonna go ahead and make sure that we change out to whatever Let's Encrypt tells us to, so it validates we are who we are, and we'll get to it. All right, so we're gonna go to the terminal, and we are gonna look at what is in that Acme challenge from here, so we can status it. So it says blah. So from a different source, we're checking that it says blah, and we will go ahead and find that. And when we add our new codes, we'll check that they're being added. All right. So here we have the dreaded red triangle for my website, hatewordpress.com. And you can get to it. It's just that you have to proceed with caution, blah, 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 right? So what do we do now? We want to add that SSL. So there's always a place to add your SSL. But first we need to add the two DNS things. So let's go back here. And we have a script. You can download the script from my website. Okay. I'll
Even if some hate words I know a few. How come?
So here it is. Once you download it, you have to change the
A lifetime of adversity, bro.
You have to change the executable level on it. Oh, sorry.
What the fuck am I
Right.
watching here? Hold on, this is only...
So now it's executable.
This is not Kubernetes. Fuck me. Twitch is sending me recommendations to make you work out. Bro. Please, not right now. After I finish this.
You landed here because you want to configure certificates so you can access your services and your
Twitch
Kubernetes
is like,
cluster securely.
get his fat ass to
you've
work.
come to the right place. Configuring certificates in Kubernetes can be challenging, but today we're going to break it all down end to end to get your cluster trusted certificates. We're going to use the ever popular reverse proxy traffic. So what we've done in the past with traffic was actually have our Kubernetes free from we want and certificate. It's because natively Kubernetes doesn't know.
I'll
what
give
it
you a
is,
few. I don't want
but
to get up
we can apply this
yet
custom
either. My
resource
shoulders are
definition
burning.
that will define resources
Thank you. I
so
appreciate that.
You can use these commands to do these things. And it's not just me doing these commands, it's so all of these services know how to interact with these objects. So, long story short, we're going to apply this custom resource definition from Cert Manager. That should apply it. And now if we do the simple, hey, get a certificate, now look, it's not giving us an error. It's just saying, hey, no resources found in default namespace. So it knows what I'm talking about, but we don't have any certificates there. So that's kind of CRDs in a nutshell. So next we would run our Helm install cert manager, jetstack, cert manager, namespace, cert manager, and pass in a values argument of our values file and then -- version of the current latest version of cert manager. So what does our values file look like? So our values file is really small, looks just like this. So I'm saying, hey, install CRDs false. Because we just install them. I don't want Helm to install them. I'll manage them outside of there. And it's a lot easier if you just apply them ahead of time than to let the Helm package manager install them. So, and then we can specify our replica count. But remember, I said I wanted it HA, so we need at least 2. We can go 3. Then we need to set some extra arguments. Now, these are really important. This tripped me up for a while. So these extra arguments are saying, hey, for the DNS01 challenge, here are your name servers. And your name servers are going to be Cloudflare, and it's going to be Quad 9. And then we're saying recursive name servers only. So why do we need this? I'm not going to explain why we need that until I explain the next couple, because it'll all make sense. Next, we're saying these pods, we have a DNS policy of none. We're not going to use DNS from the host machine. And so the pods aren't going to inherit DNS from the host machine. And then we're passing in, so we're hard coding a DNS configuration to these pods of 1111 and 9999. Again, Cloudflare and Quad 9. So now, why are we doing this? Well, so when we need to get certificates, we're going to do a DNS01 challenge, which means we're actually going to verify that we own a domain. And so Let's Encrypt is going to create a text record in Cloudflare, in our case, that we can read and verify that we own this domain. And that all works great. The problem is, if you use your own local DNS here, and you have DNS, say, for this DNS name we're going to validate, it will actually return back the IP address of the name on your local network, which is not a good thing, because then it doesn't know how to read that text record in the cloud in global DNS. So the way to get around this is to always just hard code your name servers on Cert Manager for the pod and to override any DNS that these pods are going to use. And this will ensure that it's always going to look at public DNS rather than your internal DNS. And this one especially tripped me up for a while this week. It was the pod DNS config that I didn't know I needed until I needed it. So anyways, all this is doing is telling the pods, hey, you know what? You're not going to use local DNS. You're going to go straight to Cloudflare and you're going to go straight to Cloud9 for DNS, which is fine because that's the only now depending on your resources in your cluster. And then we can run kube control get pods namespace of cert manager to see all of our pods that are running. So
that
this
feels
looks
hot.
good. We have our 3 cert manager pods. Then we have our CA injector pod, and then we have our cert manager web pod running. And they're all running, no restarts, up for 61 seconds. This is fantastic. So now that cert manager is running, we need to set up our issuer. So as I mentioned before, we want to get certificates from Let's Encrypt. So we want a new issuer. And our cluster issuer is going to be Let's Encrypt. And our cluster issuer config looks like this. So we have a cluster issuer of Let's Encrypt staging. Now let's talk about this really quick. So with Let's Encrypt, you have a staging endpoint which you can get certificates from that aren't globally trusted, but do allow you to test their API. And then they have the production endpoint, which is globally trusted, but has some rate limiting applied to it. I highly recommend you get this working 100% repeatable in staging before going to production. As I mentioned before, they rate limit production. And if you exceed the failure rate that they have set, you'll lock yourself out for up to a week. So I'd highly recommend getting this all working in staging before going to production. You've been warned. So we're going to set our server to the staging endpoint, and this is going to be your email address for Cloudflare. Now, we haven't created this secret yet, but we will create it, and this is going to be pointing to your Cloudflare token. Then we're saying our solver, so how are we going to solve, or what challenge type are we going to use? We're going to use the DNS01 challenge, like I mentioned earlier, of Cloudflare, and then we're setting our email address to our Cloudflare email, and then we're setting an API token secret ref to our Cloudflare token secret, which we'll create at the key name Cloudflare token, and then we're using a selector to say it's on this zone in Cloudflare. So that was a lot. That was a lot. Hopefully that makes sense. What it boils down to is we're just configuring a solver of DNS01 type challenge. We're gonna pass this issuer some credentials or a token from Cloudflare. We're saying it's from this zone, technotim.live, and we're gonna reference a bunch of secrets that we're about to create. So we don't wanna create this yet. We actually wanna create our secrets. So our secret is what we just talked about. So this secret is a Cloudflare token secret in the namespace of cert manager, and then some string data of Cloudflare-token, and then our token. This is a token you will get from Cloudflare in your dashboard, and that token should have read and write access to the domain or DNS that we're referencing here, so that it can create that text record and then delete that text record. So get your token, paste it here. So we can apply this secret token and create it. Then we can create our issuer for Let's Encrypt staging, and we just created it. And now we can create a certificate. So remember when we did a kube control get resource earlier of type certificate? This is actually what we're creating. So this is really awesome. We can define our certificates in YAML and have cert manager go out and fetch them, and then we can apply them to traffic later on. So we're gonna create this certificate. I'm just calling this local-technotim-live. It can be whatever you want it to be named. You can name it your domain if you want. Then I'm putting it in the namespace of default. You might be asking why I'm putting it in the namespace of default. Well, I found that this certificate needs to live in the same namespace of the service you're going to use where your ingress lives. So I'm going to deploy a service in the namespace of default, so I'm setting this to default. That'll save you some pain later on. And then I'm referencing this secret name. So this secret is going to be named local-technotim-live-staging-TLS. That's the secret name within Kubernetes that we'll use to put in our ingress later on. And then we're saying the issuer ref is Let's Encrypt staging, what we just created. The kind is cluster issuer. And then the common name and DNS names. So I'm going to create a wildcard certificate, and this is totally up to you. You can create a wildcard certificate, or you can create one certificate for your services. I'm going to create a wildcard because it's a little bit easier and it's pretty cool. But I'm creating one for the subdomain local of technotim.live. So this domain does not exist publicly. Only technotim.live exists publicly. I'm creating an internal certificate that I can use on all of my services, and I'm adding the subdomain.local so no one can resolve it anywhere. And so that if I use it internally, it doesn't match the external name. Super geeky, I know. But you can change this to anything you want. It could be example.technotim.live, and then you would do the same thing down here for this DNS name and get rid of that. And that would create one certificate on the subdomain of technotim.live. And if you didn't want a subdomain, you could do a top-level domain like this and just have one certificate. Or you can create a wildcard at that level too. You have so many options. But what I'm going to do is exactly what I showed before, which I'm creating a wildcard certificate for my subdomain. Totally up to you. So now we can create the certificate by applying this YAML, and it's being created. So how do we know it's being created? Well, let's tail the logs. So I'm going to say kube control logs in the namespace of cert manager -f for follow, and I want to follow one of these pods. I don't know which pod it's going to be. Not that pod, not that pod, it is that pod. So right here, I can see that cert manager is trying to propagate that DNS name right now. So what this is doing right now is creating a text record in Cloudflare.
Yeah, why is it? What the fuck? No, I don't get this shit. Okay. Configuring issues, issuers. Okay. Tutorials. Securing Nginx ingress. DNS validation. Then certificates from a certificate authority using the ACMA protocol. The ACMA protocol supports various challenge mechanisms which are used to prove ownership of a domain so that a valid certificate can be issued for that domain. One such challenge mechanism is DNS1. DNS1 challenge, you prove ownership of a domain by proving you control its DNS records. This is done by creating a TXT record with specific content that proves you have control of the domain's DNS records. Following issuer defines the necessary information to enable DNS validation. You can read more about the issuer resource in the issuer docs. Yeah. I am so fucking lost with this shit, bro. Where is this? Like, every time it mentions a secret, I just don't get this thing. Mm-hmm. Okay. Staging. Yeah. This is the part I don't understand. Why are we doing cloud DNS? What's that mean? Bro, I've already given you money. Certificate Management Environment Protocol is a communications protocol for automating interaction between several authorities and their users' servers, allowing the automated deployment of public key infrastructure at very low cost. It was designed by the Internet Security Research Group for their less encrypt service. Okay, JSON formatted messages over HTTPS has been published as an Internet standard often by its own chartered ETQ encrypt key. Okay. This is the same fucking URL as this one. I just don't understand what this is. Cloud DNS. What is this? Kubernetes resource that represents certificate authorities. Authorities that are able to generate signed certificates by honoring certificate signing requests. All certain certificates require a reference issuer that is in a ready condition to attempt to honor the request. An example of an issuer type is CA, a simple CA issuer as follows. Yes. This is a simple issuer that will sign certificates based on a private key. The certificate stored in the secret CI key pair can then be used to trust and assign certificates by this issuer in a public key infrastructure system. Okay. An issuer is a namespace resource, and it's not possible to issue certificates from an issuer in a different namespace. This means you will need to create an issuer in each namespace you wish to obtain certificates, and you want to create a single issue that can be hosted in multiple namespaces. You should consider creating a cluster issuer resource. This is almost identical to the issuer resource, however, is non-namespace, so it can be used to issue certificates across all namespaces. Okay, so it's just like which namespace has access to it or not. That's pretty much the only difference. Okay. Blah, 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 blah. When using cluster issue resource types, ensure you understand the purpose of the cluster resource namespace. This can be a common source of issues for people getting started with Cert Manager. Is cluster scope. This means that when referencing a secret via the secret name field, secrets will be looked for in the cluster resource namespace. By default, this namespace is Cert Manager. However, it can be changed via a flag on the Cert Manager controller component. Okay. The external IP that is allocated to the ingress controller is the IP to which all the common traffic should be routed. Enable this, added to DNS zone you control, for example. As example.com, click start assumes you know how to assign. Deploy an example service. Your service may have its own chart, or you may be deploying it directly with manifests. This quick start uses manifest to create and expose a sample service. The example service uses Quard, a demo application. Okay. You can download the sample manifest from GitHub. Edit this submit manifest given in the comment below. I think install Cert Manager to do the work with Kubernetes to request a certificate and respond to the challenge to validate it. We can use Helm or plain Kubernetes manifest to install Cert. Since we installed Helm earlier, we also may want to use Helm. Follow the Helm guide for other methods with the installation documentation for Cert Manager. So you can just install it directly with the thing, like this one right here, the static install. Okay. CRDs to configure and control how it operates, as well as the store state. These resources are issuers and certificates. Issuers. An issuer defines how certain eligible requests tell the certificates. Issuers are specific to single namespace in Kubernetes, but there's also a cluster which is meant to be class. Take care to ensure that your clusters are created in the same space. If you see issues with issuers, follow troubleshooting. Okay, certificates allow you to specify the details of the certificate you want to request. They reference an issue to define how they'll be issued. Okay. Configure as an issuer. Okay. It will download it again. Oh, thank God it didn't. Okay, why is the annotation secret name quick start example TLS? Ah, rah, 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 rah. Huh. I only fucking see 80, so how come it? kubectl get ingress. Yeah, I only see 80. Bruh. Where's my ingress file? Ingress. Networking K8 IO. Okay, it's the same. Holy shit. Namespaces. Okay. kubectl get all cert manager. Dang, cert manager. Okay. Ah. All right. What is it called? Shit. Issuer. Okay, I'm gonna call this thing cert manager staging cluster issuer, because that's what I'm gonna do. Okay, fuck it. Yeah, I'm gonna make this cluster issuer. Let's encrypt staging. Rename to .yaml. Or is it like with the C? No. Why is it bitching about that? I think it's the installation here, cert manager YAML. Cert manager releases. Okay, let's go to here real quick. Ah, we got a follower, yay! JFX2Y2, yo, thank you for the follow and welcome. Download 1302. Woody. It is in there. API version, API extension. Is that what it wants? What it should be for this? Okay, let's see. Cert manager cluster issuer unknown resource. So I have to go to my Nginx ingress. in the annotation, name of cluster issuer. I'm gonna change that to whatever it is, right? All right, let's follow this first. Where was it? Motherfucker. This is a fucking sample back and forth, back and forth. Let's see if there is something we can check out here. Serialize, I'm like cluster issuers, cluster controller. Okay. Cert manager IO. Oh, this is bitching to us. It's not. Okay, whatever. So, email address to use for ECMA registration. Okay, fuck it. Let's encrypt staging. Okay. I'm just gonna rename this thing to like something shorter. Staging. Okay. It actually accepted it. Doesn't have a namespace, right? No. Okay. Production issue. Yeah, we're gonna skip that. Annotations in the ingress. Yeah, that's the name that we created. Okay. And then ingress class name is that, and then TLS, and then secret name quick start example TLS. What the fuck? Yeah, where is this coming from here? What the fuck are you doing? This is jumping back and forth. kubectl get secrets. It restarted 12 times. What the heck? Yeah, it's doing the cluster issue here too. So actually, I'm gonna fucking staging. Shit. What did I name that file? Sort manager. Okay, it already exists because we did run it, so we are good. Okay, this is the prod. Yeah, we don't want to do that. Okay, that's enabling pod communication through the load balancer. So I'm gonna put that to my ingress thingy here. Ingress roles. That's in the controller. Fuck. No. Coco, what you doing, big boy? Coco is good boy. Yes, my kitty. Okay, where the fuck is this coming from? So in here, whatever you name this thing, it will create it for you. TLS hosts. Kind ingress. Okay, hosts, TLS hosts. Okay, we're gonna do filelib.com and then api.filelib.com. And then let's do this echo TLS. What? And here the secret name. Let's create private key. Let's encrypt staging. Okay. This is in the ingress. Yes, my boy. Guys, one sec. I'm gonna follow this boy and see what he wants. Probably gonna make me open the door. You're gonna make me open the door, Coco? Yeah. Hey, kitty. Yes, you good boy. Where's my boy? We're back. He's like trying to go outside, but it's raining, and he just doesn't. He just wants to sit at the door with the door open. Okay, so the first one you mentioned at the ingress, but all the previous things we created, we haven't mentioned that private key secret ref. Oh, okay, that makes sense. I think I'm kind of getting it now. Secret name. So the secret name is supposed to match this here in the ingress. Let's encrypt staging. Or I'm just gonna say staging secret. Okay, so if I'm looking at this one over here, for example, it says let's encrypt staging. It's the same shit. I'm gonna fucking let it go and then see what the heck will happen. Okay, fuck it. So this comes right in here. This is like the, okay. So when you do apply the ingress, okay, let's go apply the ingress. I don't know if it's gonna work. Echo TLS. The way he meows. Okay. Yes, Coco. What? We changed it. I removed the namespace. Alright, fuck it. Now deploy an example service. Okay, deploy ingress. Okay, ingress. Yeah, we don't do that. Ingress nginx. That's the one we did. User guide, basic. Yeah, we are good with that one. Cool. Doesn't fucking show up, is it? Yes, Coco. So in our thing here, we have max body size. Nginx config map. What? I need the config map just for Nginx as well. How do you specify, how do you assign the config map? Okay, yeah, I see that I can do that, but yes, Mr. Kitty. So it's just a config map and then name Nginx config namespace. But how are you supposed to reference this? Isn't this something that you reference? Coco, we can't open the door, baby. It's too cold. What? It's too cold, guys. Hold on. I'm gonna go see one more time. He's out. Okay, I can come back to this. New file, Nginx config map dot YAML. Okay, client max body size. We're gonna make this 65. Okay, we're fine on this thing. Namespace. We don't know. Nginx config. Okay, and now I can say kubectl apply k8. Nginx config map created. Nginx ingress config map. How are you fucking okay? I don't get this shit. Okay. Get pods, okay. kubectl, get ingress. Okay, kubectl, describe ingress, filelib ingress. Okay. labels, namespace, ingress class, default, TLS, echo terminates, backends, Next.js, service annotations, staging, yabbity. Like I have to have a the ingress doesn't fucking show up. Like, am I tripping here?
Nginx, Ingress, full example. Not the fucking controller, man. Huh.
Well. Okay, let's close tabs to the right. I need to get back to what the hell I was reading here. I think this one. Q88. Okay. It says unchanged. I don't know why, but describe certificate. It's not found. This motherfucker is coming from another thing, like it's coming from this thing. Helm install quick start. Where the fuck is this coming from? It's fucking right there. Pods. Motherfucker. Start server Filelib. There you go. I don't see no fucking client. Max client body size. Client max body size is 1 megabyte. Yeah, that's not good. So it doesn't look like it fucking cares about that. I fucking hate these documentations like this. Ah. Hmm. Filelib ingress configured. How the fuck are you supposed to get controllers? kubectl get all controllers. You are here? Huh? You are here? You are outside under the rain, Mr. Kitty? Huh? You walk under the rain? It's my point. I really, really fucking hate this shit. I want it like rebuilt. It is still 1 meg. This is really fucking stupid. That's like literally what I have. Coco, baby, I don't know what you want. Like, I'm doing everything you want. Like, you won't let me work. You're gonna be poor, Coco. I don't know what he wants. He wants something. This is so fucking stupid. I hate that like the fucking documentation uses an existing application. Like do it for us so like we can see where things are coming from. It's referencing a secret that I don't understand where. Did I type it correct? Okay. Nginx ingress, let's encrypt. Fuck it, let's see.
Hello everyone, in this session we are going to cover how to set up Nginx ingress controller with Let's Encrypt SSL. It includes cert manager and TLS. So we are going to implement HTTPS on Nginx nodes, one master node and one worker node. So let's start Kubernetes Nginx ingress controller with Let's Encrypt SSL. So here we have the steps. Okay. So first step is to install Helm 3 on Kubernetes cluster. So first we will set up the Nginx ingress controller. Then we will set up the Let's Encrypt. It includes cluster permission of it. Let's check the 5.4 is installed on Kubernetes cluster. The Nginx ingress controller on Kubernetes cluster using Helm 3. So here you can go through the official Nginx ingress document to install the latest Nginx ingress controller. Here we have the instruction to set up the different instruction. So ingress name, ingress engine, Helm ingress. Let's update the Helm repo. Command is Helm repo update. Next, let's install Nginx ingress controller.
Throwing me off with the way he's speaking, bro.
Hello, my name is Shailendra Chaudhary, and in this video I'll show how to use Certificate Manager to secure custom domain. Let's encrypt creating if it's reachable through this public IP which is created in the load balancer, and this public IP is custom defined according where all commands are. As there are a lot of steps as well as the commands to be followed, so I thought it will be easy for you if you'll follow this blog. Let's start the lab now. So we'll be using the same AKS demo cluster.
Oh shit, before I forget, I was trying to find quick start ingress and quick start. Where the fuck is this coming from? Helm. Okay, where is there? Okay, GitHub and Helm. Charts. Absolute these chart museum, chart testing, chart. Quick start guide. Install Helm. And the headset is dead. Hold on, I'm gonna have to use this. Is it using this still because it's dead?
This is our Cert Manager dashboard defined as a JSON object.
There was like a GitLab here. Okay, hold on. Let's read everything here. Fuck it. We're gonna come down. Service.yaml. What is this? Rancher demo. Selector app Kubernetes IO name rancher demo session FND type cluster IP. Ingress rancher demo nginx ingress Kubernetes rewrite target. Okay. Certificate. Okay. Secret name SSL cert staging.
Reference our issuer we just configured. So for the staging certificate, we obviously reference our Let's Encrypt staging issuer. Yeah, and as you can see here, common name is necessary and DNS name. So we need to fill this out. Staging. We need to fill this out. And this is just our IP address. I will copy this from here. And here. And this is a list. So if you have multiple domains or multiple subdomains, you can list them all in this certificate here. So there's not necessary that you need to create a certificate for each subdomain, but you need to list them here that you can, obtain a certificate maybe for this domain, but with multiple subdomains. Yeah, easy as that. So we will put this here, and we need to do this again for the production one. So change this here and here as well. Okay. And then, last but not least, we need to apply them. Kube control apply -f certificate, staging YAML, and production YAML. Let's check if this worked. Kube control get certificates. Both are false right now. So let's wait a second. Sometimes it just takes seconds. Sometimes it takes a minute.
I don't have
it
enough.
Took like a minute for the staging certificate, but the bad news are that for the production one, it tells me that we exceeded the rate limit for the domain nib.io. So that's exactly what I pointed out in like 3 to 5 minutes ago in this video. If you use domains which can be used from everyone, like nib.io, then there will be a rate limiting from Let's Encrypt. If you have your own domain, you won't run into this issue. What we can do now, or what will I try to do is, I will try to edit this certificate, and I will use another provider like Let's Encrypt, like nib.io, but another provider would be traffic.me. Let's see if we can get a valid certificate for this one. Hey, that worked. So there's no rate limit right now for the traffic.me domain, which is exactly the same like nib.io, just another ending of your domain. And we received a certificate for this one. So little hiccup, but not everything works like a charm in the DevOps world, right? So just keep that in mind. And if you use, as I said, your own domain, you won't run into this issue that fast. Now we have our certificates, as you can see here. We have staging one, which is true, and the production one, which is also true. So what we need to do next, or as a final step, because our demo application is still running on nib.io with the invalid certificate. So I will go back, and we have our ingress resource here. And I pointed out at the beginning that we need to make some changes here to actually make use of our certificates we just got. So
can search or go to, okay, so I'm gonna search for this secret name. No, you fucker. I'm searching it in this thing here. All right, it's on this one. This is one. SSL cert production. Okay. Ah. All right, let me listen to this guy. It's like I'm not making any progress anyway.
So how many SSL certificates do you have in your Kubernetes cluster? And on top of that, how many Kubernetes TLS certificates can expire? There are two things that come to mind here. Number one is human error. The more Kubernetes clusters and namespaces you own, the more secrets you have to manage and maintain. There is also room for error when replacing these secrets, and you are always bound to miss one or two and have downtime. This adds a lot of unnecessary operational overhead. Number two is security. Long-lived SSL secrets that don't expire until 2 years is not great for security, and humans interacting with these SSL certificates means that it's leaked from the moment you get them. Now you can protect these SSL certificates in secrets in Kubernetes using RBAC, but that means cluster admins can still retrieve them. If you have a few cluster admins that maintain Kubernetes and create these secrets, the chances are your certificates are already leaked. Managing certificates manually is an operational burden that is not worth risking. Let's Encrypt is a certificate. To get a certificate, Let's Encrypt provides a challenge, certbot fulfills the challenge, Let's Encrypt provides the certificate. This process can be automated with a cron job. Familiar with Let's Encrypt, check out my Let's Encrypt introduction. How does this work in Kubernetes? If we have multiple domains and we need multiple SSL secrets in multiple namespaces, how do we automate the lifecycle of all these certificates and keep them secure? This is where Cert Manager comes in. Cert Manager lives in your Kubernetes cluster. You wire it up to a certificate authority like Let's Encrypt, Vault, and more. We simply ask for a certificate using a YAML file. In the YAML file, we simply say the domain we need a certificate for, and the secret where we expect the certificate to be stored in. The Cert Manager will talk to the CA and place the new certificate in the specified Kubernetes secret. The Cert Manager will also replace the Kubernetes secret with a new one when it's about to expire. This means free and automated SSL certificate generation and full certificate lifecycle management. So enough with all the theory, show me the code. To get started, if you take a look at my GitHub repo, I have a Kubernetes folder, and in the Kubernetes folder, I have a Cert Manager folder with a README, and in this README, I have all the steps that I'm going to be showing you guys today. So be sure to check out the link down below to the source code so you can follow along. So to
Oh
get
shit,
started,
we got
the first
someone
thing we're going to use is a
messaging.
Kubernetes cluster.
Kurt
So for this,
Bedine,
I like to use a utility called
how's it going, my
Kind,
dude?
which
Sorry,
allows
I
me
missed
to
your
spin up
message.
lightweight Kubernetes clusters really fast that I can use for testing. So to create a Kubernetes cluster, we're going to say kind create cluster. We're going to give the cluster a name called Cert Manager, and we're going to run Kubernetes 1.19.1. So I copy this command, paste it in the terminal, and that will go ahead and create a Kubernetes cluster that I can use for testing. And then once my cluster is ready, I can say kubectl get nodes, and we can see we have a one node Kubernetes cluster. A kind create cluster, we're going to give the cluster a name called Cert Manager, and we're going to run Kubernetes 1.19.1. So I copy this command, paste it in the terminal, and that will go ahead and create a Kubernetes cluster that I can use for testing. And then once my cluster is ready, I can say kubectl get nodes, and we can see we have a one node Kubernetes cluster up and running, ready to go. So if we take a look at the Cert Manager GitHub repo, they have a nice description of what the project is all about. We can see we have Cert Manager over here. Cert Manager looks at a bunch of issuers, and we have Let's Encrypt support. Cert Manager also looks at certificate objects, which we can deploy using a YAML file, and then it translates the certificate object into a Kubernetes secret. It also points us to the official documentation, which also has a good description of what the project is all about, as well as the concepts. And in the concepts, they talk about the issuer, how to wire up Let's Encrypt to Cert Manager, how to define certificate objects, and they talk about certificate requests, ACME orders and challenges, webhooks, CA injectors, and the project maturity. Now we'll take a look at these concepts in a second, but if we go back to the GitHub page and we go to the releases section, you can then choose the release you want to deploy to your environment. And if you scroll down under assets, you'll see the Cert Manager YAML file that defines everything you need to deploy to your Kubernetes cluster. So you can either download the YAML file directly from here, or you can use something like curl and download it. So to download Cert Manager, I'm going to change directory to my Kubernetes Cert Manager folder, and then I'm going to run curl, and I'm going to run curl against the releases page URL, and I'm going to download version 1.0.4 of the Cert Manager YAML file. So I go ahead and run that. That'll download the YAML to our machine, and then I'm just going to rename the certmanager.yaml to certmanager-1.0.4.yaml. Then to deploy Cert Manager, I'm going to create a new namespace for it. So I'm going to say kubectl create ns cert manager, and I'm going to deploy Cert Manager saying kubectl apply validate false -f, and I'm going to pass in the Cert Manager 1.0.4.yaml file that we've just downloaded. So if I do that, that'll go ahead and create all the custom resource definitions, cluster roles and role bindings, RBAC permissions with a service account with our Cert Manager deployment. Then to see all the resources that have been deployed, I can say kubectl in the Cert Manager namespace get all, and we can see we have a Cert Manager pod coming up. We have a Cert Manager CA injector pod, as well as a Cert Manager webhook pod. We also have a service to expose the pods. We have a deployment, and we can see there's no external IPs being exposed directly to the public. So it's nice and secure within its own namespace. And if I do kubectl in the Cert Manager namespace get pods, we can now see we have all three components up and running, ready to go. So now that we've deployed Cert Manager, we have to go ahead and hook it up with a certificate authority. In this demo, we'll be using Let's Encrypt. Now Cert Manager will be deploying a bunch of custom resource definitions, so new Kubernetes objects are introduced in our cluster. So to hook up Cert Manager with Let's Encrypt, we need to deploy an issuer.yaml. Issuers is a YAML file we'll deploy to define certificate authorities. In our case, it's Let's Encrypt. Then we'll deploy another YAML file, which is the actual certificate we need. Then everything else will happen automatically. Cert Manager will generate a certificate request object, then an order object will be generated used for the Let's Encrypt certificate order, a challenge object will be generated used to fulfill the Let's Encrypt challenge. When the challenge is fulfilled by the Cert Manager, the certificate status is automatically completed and a Kubernetes secret is created or updated. Now before we go ahead and use a real CA, let's quickly test out whether our Cert Manager works by creating a self-signed certificate. So to test certificate generation, I'm just going to create a temporary test namespace. I'm going to say kubectl create ns and create a namespace called Cert Manager test. Then if you take a look at my GitHub repo under Kubernetes Cert Manager, I have a self-signed folder with a self-signed issuer.yaml. And if we take a look at this is what an issuer looks like. So we say kind as issuer, and here we just say that it's a self-signed issuer. So to deploy the issuer, I say kubectl apply -f in the self-signed folder, and I apply the issuer.yaml file. This will go ahead and create the issuer for our Cert Manager to use. Then I can go ahead and request a certificate by creating a certificate.yaml. And in here we can see that kind is certificate. We give it the namespace to deploy the certificate to. We also specify a DNS name for our certificate. Then we also specify the secret name where to put the actual self-signed certificate. So the Cert Manager will go ahead and request a certificate from the issuer and place the certificate in this secret called self-signed cert-tls. And also for a certificate, we have to tell it what issuer to use. So in this case, we say issuer reference, and we tell it to use the self-signed issuer that we've just deployed. So to create that self-signed cert, I say kubectl apply -f in the self-signed folder, and I apply the certificate.yaml. That'll go ahead and generate a certificate. The Cert Manager will look at that certificate, create a certificate request for the issuer, and then create the secret for us. I can then go ahead and describe that certificate by saying kubectl describe certificate in the namespace Cert Manager test, and we can see here that we have our self-signed cert in the Cert Manager test namespace, kind is certificate, and if we scroll down we can see the events and statuses. So we can see that issuing certificate as the secret does not exist. It stored a new private key in the temporary secret namespace. It created a new certificate request, and the issuer has gone ahead and the certificate has been successfully issued. To view the certificate, I can list the secrets in that namespace, and we should see that a self-signed cert TLS has been created as a secret in our cluster, ready to be consumed. So that is the very basics on how certificate generation works. Now Cert Manager has great documentation around the configuration. So you can see here that it supports multiple issuer types. Self-signed, which is the one I just showed. You can use a CA, a Vault, as well as the ACME issuer, which is Let's Encrypt. Now in order for the ACME issuer to work, your cluster has to have the capability to solve Let's Encrypt challenges. Now usually in your Kubernetes cluster, you have an ingress controller that accepts public traffic. Now we're going to be using an existing ingress controller to accept incoming web requests for the Let's Encrypt challenge. This will allow us to solve the Let's Encrypt challenge. If you're not familiar with the Let's Encrypt challenge process, check out my video down below on the introduction to Let's Encrypt, where I show the full process and a walkthrough of how to run it all locally. So let's go ahead and deploy an ingress controller to our cluster. You can also feel free to use your existing ingress controller. So to deploy an ingress controller, I'm going to create a new namespace called ingress-nginx, and in that namespace, I'm going to apply the installation YAML file for the ingress controller version 0.41.2, and I'm going to take that YAML file and apply it to my Kubernetes cluster. That'll go ahead and deploy an nginx ingress controller to our Kubernetes cluster that we can use to take traffic. Then to see the ingress controller up and running, I can say kubectl in the ingress nginx namespace, I can say get pods, and we can see we now have our ingress controller up and running, ready to go. We can also see if I say kubectl in the ingress nginx namespace get service, I have an ingress controller service type load balancer here that's looking for an external IP. If you're running in the cloud, you'll get an external IP or a DNS name, but because I'm running in a kind cluster, I won't be getting that. So what I'm going to do is I'm going to port forward to port 80 and port 443 so that I can access this ingress controller. So to do that, I'm going to open up a separate terminal and I'm going to say kubectl in the ingress nginx namespace. I'm going to bind to 0.0.0.0 address and I'm going to port forward to the ingress controller on port 80. I'm going to go ahead and run that. That'll port forward to my ingress controller, and then I'm going to open up another window and I'm going to do exactly the same command, but this time for port 443. So I go ahead and run that, and now I can open up localhost in the browser and I can hit my ingress controller on port 80, and we can see it's up and running, but there's no routes defined, so I get a 404. So now that I've deployed an ingress controller to my cluster, let's go ahead and get the public IP address of this machine so that we can hook up a DNS record to this IP address. So to do that, I'm just going to say curl ifconfig.co and I'm going to grab the public IP of this server. Now if you're running in the cloud, you'll probably already have a public IP address on your nginx ingress controller, so you can just go ahead and use that. So what I'm going to do is I'm going to grab this IP address and I'm going to head over to Google Domains where I have an existing DNS already created, and I'm going to go down to custom records and I'm going to add an A record with that IP address that we've gotten from our server. Once I've updated that, I have to wait a while for DNS to propagate, and once it's propagated, I can type the DNS in the browser and I can access my nginx ingress controller, and we can see that we don't have any SSL certificate, so it's coming up with this warning, but now our ingress controller is publicly accessible. So now that we have a Kubernetes cluster with an ingress controller that can take traffic, and we also have cert manager, let's go ahead and deploy a Let's Encrypt issuer to our cluster. So similar to our self-signed issuer YAML that we have here, we also created a cert issuer nginx ingress YAML, which is a cluster issuer for Let's Encrypt. So we say kind is cluster issuer, we give it a name, and the name is Let's Encrypt cluster issuer, and then we specify a spec with the ACME settings. So we specify the server, and this is the production server for Let's Encrypt. We give it an email address. We also specify a secret where it can store the issuer key, and there are different solvers we can use. We can either use a DNS solver or an HTTP solver, and for this example I'm going to use an HTTP solver and point it to the ingress class, which is nginx. So to deploy this Let's Encrypt issuer for our cluster, we're going to say kubectl apply -f, and we're gonna.
All right, y'all, I'm gonna continue this tomorrow. I'm like way out of zone and tired, and my brain is all over the place. I need to recoup, chillax, and then continue with a fresh mind tomorrow. I was hoping to finish this today, but it's not gonna work. So thanks for watching, and I'll see you guys tomorrow. Good night.